All right, let's go ahead and just get rolling. And I think that more people will kind of trickle in. But I'd love to introduce myself, Jamie Smith. I'm one of the 3 co-chairs for CCHABs. Also on the line is Becky Stanton and Sarah Ryan, who are my other CCHAB co-chairs. If you want to quickly pop on and say hi.
Good morning, all. Thanks for joining.
Hi, everyone.
Awesome. And we're really glad, happy 2023. We're excited to we have a full schedule today. It's our, for those of you who are newer to CCHABs, usually our December/January meeting is our longer meeting where we hear from all of our, annual updates from all of our partners and members that do routine monitoring. So the FHAB program and regional boards that do monitoring, as well as local partners. So we'll start off. We have a couple of announcements. So I think on the docket, Sarah, you had a couple of you had an announcement you wanted to make. If you want to start.
Well, it was just, I had a small presentation on the kickstarting. So you want me to go ahead and do that?
Yes, go for it.
Right. Hey, everyone. So I'm Sarah Ryan. I'm the environmental director for the Big Valley Band of Pomo Indians. And I've talked about this a little bit before, but I wanted to spend a few minutes talking about a workshop that Big Valley has been leading for tribes in California, as well as in another area. It was actually Wisconsin that we did a presentation. And we have what we call a kickstarting a cyanotoxin monitoring program, about 100-page manual that covers, in this particular case, we crunched it all into one day, but we actually have a week-long workshop that we've done. And we are in April of 2022. And then we had a one-day that we did in Wisconsin at the Tribal Lands and Environment Forum, which is sponsored by ITEP, which is the Intertribal Environmental Professionals group that is nationwide. So this program is, we think it's really important because we know that there's not a lot of cyanotoxin monitoring that's going on with the, with local governments because they don't have the funding for it. But tribes doing cyanotoxin monitoring is it's sort of a no-brainer because they're already many tribes have water quality monitoring programs that are funded by US EPA. They might also have some state grants and some local grants and their own funding to do cyanotoxin monitoring. And we're really trying to give the message in our workshops that we're doing that, number one, it's something that, is definitely part of a Clean Water Act implementation program. And it is also can be protective of tribal beneficial uses. So in our workshop, and I'll actually share part of our binder, we do go into what is not only cyanotoxin, what's going on in terms of the local jurisdictions and the state in terms of their programs, but we also have a lot of field guides in there and some site visits that we did with our week-long that basically helps people with some hands-on identification of cyanobacteria. And then, we get into the nitty-gritty of the Clean Water Act and how monitoring and providing the data in a way that it can be used about the 303D evaluations that happen. That it's a really important thing for tribes to be out there monitoring and to submit this data. We go into the logistics of the I'll move forward to the shipping, the monitoring itself. Like I said, we do link it to state programs that are out there. and we also identify like what is the context of the results that you're seeing. And of course, we're using state of California's for a lot of it. So just wanted to put in a plug for if you've got some tribes in your area. The workshop that we did in April had 14 people from 4 tribes. So it was the Viejas tribe that is in Alpine, California, Buena Vista tribe that is in the Sacramento area, the Santa Rosa Taichi Yokut tribe, which is in Central California, and Coyote Valley Band of Pomo Indians, which is in Mendocino. So those 4 tribes did take our week long that we did in April, and we've got another week long that we're finalizing the dates, but it'll be by early summer this year. And if you have tribes that are in your area that want to have more information about all of these things and understanding the signage, cyano identification, we talk about microscopy and just identification through that. Like I said, we also go into the logistics of it. So if you've got tribes who are in your area, reach out to them and let them know to contact us, because we're going to be putting out the request for people to sign up for our workshop. And also we're happy to share this binder for your own information. We've put together this program over at Big Valley. Elam Indian Colony was a part of the setup of it, but we've been implementing this program since 2014, and we think it's been it's grown. We've figured out how to do various things so that we're able to do our documentation and have good results out of it, including how to communicate to the public. So I just want to put a plug in for that. Keep an eye out for when we're doing our workshop. It is only for tribal professionals, but we're happy to share the binder and certainly answer questions as time goes on for any of you or anybody in the state. Thank you.
Great, thank you, Sarah. Becky, I think you had a quick announcement, and then we can move on to our next agenda item.
Sure. Hopefully you got it through the email listserv as well, but I know that the U.S. Hab Control Technologies Incubator is accepting letters of intent from basically yesterday until the end of the month. So it's there's some great links. I'll put it in the chat too, but it's kind of taking the next step in terms of like proof of concept for Hab mitigation. So certainly we'll hear later from our mitigation subgroup, but if anyone's interested, we're glad to see those opportunities, and certainly happy to have anything that can help us out in California. I think it's because it includes Great Lakes area in the overarching NOAA, then it includes freshwater HABs as well as marine HABs. But I'll put the link in the chat. Thank you.
Awesome, thank you, Becky. All right, so we're going to move on to our next agenda item, which is updates from the FHAB program as well as regional updates. And so let's start with FHAB program updates. I see Marissa, do you have some slides you want to share?
Yeah. Can you make me co-host so I can share? Or I'm just going to try.
Yeah, you should be already. Okay. Perfect. Go for it.
Great. Okay, you guys can see my screen. Great. Hey folks, I'm Marissa Van Dyke with the California Water Board's Freshwater and Estuarine Harmful Algal Bloom Program. Along with me is Carly Nelson as well. We're going to be tag teaming along with our regional coordinators on our updates. And just to reiterate this section, as Jamie had introduced, it's for statewide and regional program updates. So any entity that's monitoring is very welcome to provide updates on what you've experienced past summer, past year, that kind of thing. So I'm just with the California Water Boards, and wanted to highlight again who we all are. So we have the Freshwater and Estuarine Harmful Algal Bloom Program that's implemented statewide. Up here, here on the right, we've got our names of our program kind of leadership. And primarily we coordinate incident response to reports that are submitted to our online reporting form. We manage and keep up to date the California HABs portal, along with any content developed by the CCHAB members. And we're also coordinating monitoring and response coordination, communication, and other kind of outreach activities. So we wanted to give you a snapshot again, and a reminder again for folks that have been with us for a while, where we are all located. So we have 3 full-time staff in the North Coast region, Central Valley, and in the higher elevation Lahontan region, and then part-time staff at the other regional water boards that we closely work with. And some of them will be providing updates in their respective areas shortly after my kind of slides. And Karen Atkins, she's listed here for Central Valley. Actually, this week she started with the Department of Fish and Wildlife to lead the implementation of their freshwater and estuarine harmful algal bloom program. So we'll be updating that soon. And kind of primer again, that the California HABs portal is kind of the one-stop shop for all resources, HABs, particularly from governmental agencies and partners of CCHAB that we develop. And we have mapping tools, communication about health and human health and animal safety. There you'll also see find the CCHAB statewide voluntary guidance, and also a field guide and standard operating procedures to help coordinate field sample collection and how to then interpret it against this guidance. And for any time that you want to contact the folks that manage the portal or FHAB program in general, we've got a general inbox listed right there. And then within our program, we implement CCHAB's statewide response guidance for recreational waters. This again, includes planktonic and benthic bloom guidance on how to respond, including flow charts and trigger levels, which most of us are familiar with. This is a little primer again. With our response and that kind of coordination, on the portal there is a map that presents all of the reports that are voluntarily submitted to us, and then results from our investigation, and if there's any appropriate advisories to recommend are presented. This is a snapshot of the map over like the last summer, kind of give you an idea of it. We're seeing an increasing trend of HAB reports since we began tracking. Here's a snapshot just from like the last 4 years of the amounts of reports that we've received that we've evaluated. And then we also, on our online reporting forum, can ingest any suspected HAB-related illness reports. That's also tracked there, and these are just ones that are for evaluation, and we're still getting our 2022 numbers ready. We'll have an update later on that. All right, and with the program's implementation now through the Assembly bill for a couple of years, this is just a reminder of what the Assembly bill kind of requires of us, and that established the formal freshwater and estuarine harmful algal bloom program, the water boards and CDFW. We're working to establish a statewide comprehensive monitoring program and better collaborate with our partners. It's something that we've been working on extensively this past year. And also this past year, we did a gap assessment. So kind of understanding what gaps there are to fully implement all of these objectives through the water board's regulatory programs, policy, and permitting, and so forth. And so we did that as part of our, and we've submitted that as part of our annual reporting requirements for this Assembly bill. And we, in that gap report, we also identified that with the Assembly bill asking for additional recommendations and other actions that we should take to better protect water quality and public health from HABs, we've also noted that we're supporting the development of standards, water quality objectives and standards. We highlight that that's something that is integral to better implement the objectives of the bill, and we have And that was also highlighted in our gap assessment. Because as we can see here with our trend of tracking of our reports, with our report tracking, we've noticed that there is quite an increasing trend. And when we've done some forecasting using a few different tools, when we felt most confident in, we're seeing that the reports are just going to continue increasing and exceeds our resources that we have. And so one of the takeaways for from our program, just kind of our year-end summary, we had our annual report that articulates what we accomplished and what we're working towards. So we have a web page that provides all of that kind of reporting requirements that you can take a look at if you want to see the legislative report and the gap assessment. And it's under the program SWAMP at the Water Board's website. All right, and I'm going to now just kind of conclude our statewide kind of update and hand it off to go through any regional coordinators at the water boards and any other entities that'd like to present as well. Thank you.
Awesome. Okay, so if we have, I know we have several regional hub coordinators that had wanted to provide an update. I think we'll go ahead and start from the north. So if Mike, I know you had an update from the North Coast, so if you want to go first, let me know if you have it sharing your screen.
Yep, I can try to share my screen here. 1 second. All right, can you see that? Great. Okay, yeah, my name is Mike Thomas. I'm the FHAB coordinator for the North Coast region. I'm just going to give you a quick 2022 season recap. First, I wanted to say a lot of what we do in the North Coast region would not be possible without our partner agencies, some of which are listed here. So we produced an end of summary document for the North Coast region, and I'm just going to run through some of the items that are in that report. Shown here is a table of the overview of our postings in the region in 2022. You can see it's broken down by planktonic and benthic across the top, and then report type, whether that be routine monitoring, pre-holiday assessment, incident response, or studies and research. What you can see is most of the postings in our region are benthic postings and rivers. And a lot of our planktonic postings this season were the result of routine monitoring. So the routine monitoring that did occur, Big Lagoon Rancheria, and US EPA, we're doing microsystems monitoring up there. In the Klamath Basin, shown to the right there, we had the Hoopa, Karuk, and Yurok tribes, as well as Pacific War and US EPA conducting microsystems monitoring. And then Tule Lake and Lower Klamath National Wildlife Refuge was being monitored by the US Fish and Wildlife Service. And they were doing the 4 cyanotoxin suite and cyanobacteria ID. So for pre-holiday assessments, you can see the 12 water bodies that participated this year. In the first half of the season, you can see there weren't that many postings except at Lake Pillsbury and Copco Reservoir. Then in the second half of the season, we definitely had more postings with Big Lagoon and Copco Reservoir reaching danger. And here's a table summarizing the 4 illness reports we got this season. There were 2 human illnesses confirmed in the Russian River. And these were largely confirmed due to positive cyano detections at nearby monitoring sites. There was a dog illness in Ruth Lake that was determined not to be HAB related. And then we had a report of a dog death in the South Fork Eel River, and this was inconclusive. Some studies and research. We worked with the State Board, Quartz Valley Indian Reservation, and University of Nevada at Reno and CSU San Marcos to do some more benthic monitoring in the region. The regional board also conducted a SPAT pilot study in 2 rivers here, and we were deploying SPATs weekly for 17 weeks just to use them as an early detection tool for FHABs, benthic FHABs. Also in 2022, we released 2 reports shown here. The benthic report summarizes data collected over a 4-year period and ultimately provides monitoring recommendations for benthic FHABs. Then we released a SPAT report detailing a study conducted in 2019 on the appropriate use and deployment lengths of SPATs. And we ultimately recommend a 4 to 8 day deployment length there. But both good reports, so be sure to check them out. They're linked here. And here's just listed other reports, presentations, and trainings that were provided this year in the North Coast region. So with that, I think I'll pass it on to whoever's next.
Great.
Thank you.
Thank you, Mike. Do we have anyone else in the North Coast region that would want to provide an update? Okay, then let's go down the coastline and do region 2 next.
Hello.
Hi, Rebecca. Do you need me to let me make you? Do you have slides to share, or are you just going to do an oral update?
I do have a couple slides.
Okay, let me make you co-host. All right, you should be good to share your screen now.
Okay. Can you see the not presenter mode ones?
Yes, we.
Okay. Perfect. Okay, hi everyone. I'm Rebecca Nordenholt. I'm one of the FHAB coordinators at the San Francisco Bay Water Board. And so our recap from 2022, this is a map that hopefully captures the worst case scenario we had last year for a recommended advisory for all of the different kinds of reports we had. So that includes holiday sampling, incident response. We had a marine bloom of red tide, which I'll touch on more in a minute. And then, of course, our partners at East Bay Regional Park District do weekly monitoring at their water bodies. So we did holiday assessment this year, and so these are the water bodies that we chose and the reasons why we chose them, the kind of recreation they have. And the worst advisory they had throughout the season. And most of these were because of either algal mats or in Lake Merritt, there were some wildlife deaths prior to the holiday assessments, which was another reason we decided to sample there. And it ended up having levels of saxitoxin and cylindrospermopsin came back in the samples throughout the year for all of the different holiday sampling. And then here's a summary of our incident response and illness. So we had a couple of confirmed human illnesses, and there was a dog death, and maybe someone, Becky can maybe correct me if I'm wrong. I don't think it was ever concluded. It was kind of a strange situation where the dog died, and then when I went to go collect a sample, the place where they told me the dog went swimming didn't have any water. So not really sure what actually happened there. And then we had a couple of other human illnesses or wildlife deaths that were not HAB related. Okay, and then the big thing that happened for us last year was we had this red tide in the San Francisco Bay, and it sort of bled into a lot of the estuaries that are connected to the bay. So it was first reported in late July as a sewage spill because the kind of algae it was, Heterosigma akashiwo, looks kind of like brown, muddy, or rusty red water. And so it started out in the Oakland estuary and it moved into Lake Merritt in early August. And then sort of as August went on, it expanded throughout the bay and it ended up all the way up into San Pablo Bay, throughout the bay. By late August, we started having fish kills throughout the bay and in Lake Merritt. And we have monitoring data that shows Theo crashed. And so we had a lot of really dramatic fish kills because of that. And then by early September, thankfully, the bloom dissipated. And so here's just a quick summary of what we did in response to the red tide. I'm definitely not going to do it justice, but a big part was the nutrient management strategy. So that's a collaboration between researchers, regulators, and dischargers to study the impacts of nutrients in the San Francisco Bay. And so the municipal wastewater treatment plants that discharge to San Francisco Bay collectively contribute $2.2 million per year to fund about 80% of the nutrient management strategy budget. And so this program is primarily led by the San Francisco Estuary Institute, and they routinely monitor for HABs within the bay. And so then there was emergency funding allocated to study this particular bloom. And a result that will most likely come because of this event is so this program is because of the NPDES permit, the wastewater discharge permit. And so the next time the permit is adopted, there will most likely be some sort of nutrient cap or requirements for reductions as a result of this bloom. And so then in addition to that kind of monitoring in the bay, we collaborated with a bunch of basically all of our sister agencies that might touch on HABs and local governments, parks, state parks, nonprofits, to share information with each other and with the public, so we could, tell everyone what's going on and how to stay safe. And kind of one silver lining of this is we have hopefully identified a new partner agency, a nonprofit at Lake Merritt that's very interested in monitoring for algae there and just water quality in general. So we're hoping to get them set up to do some partner monitoring this year. And that's all I have.
Awesome. Thank you, Rebecca. I know that we typically also hear from, excuse me, East Bay Parks. I don't know if someone's on the line that would want to provide an update. I can give you, and if you want to share slides, let me know. Hi, Sabrina.
Hi, I don't have any slides to share, but I'll give a verbal update.
Great.
Okay, so East Bay Regional Park District's regular HAB monitoring program. We did have 3 danger designations come in towards the end of last year. One was at Horseshoe Lakes at Quarry Lakes. One was at the Arroyo Dog Access Area at Shadow Cliffs Lake. It's technically behind Shadow Cliffs Lake. And then the third was at Del Val Reservoir. So we haven't been back out since all of this crazy rain. So we're hoping that our designations will, drop off. But as of right now, they're at danger advisories. And Del Val, because of all of the rain, we actually had to flood the park in order to stop an overflow of water going into the surrounding neighborhoods. So right now that park is totally closed and we're not able to do any monitoring there until the water level starts receding again. In terms of red tide updates from late last year, so our shorelines were impacted. Point Pinole, Miller Knox, Encinal Beach, Crown Beach, MLK shoreline, and Hayward shoreline, we all had reports of fish kills over the course of about a week. At the end of August, we received about 50 fish kill reports at those varying locations, mostly sturgeon, interestingly enough, and some striped bass. But other than that, it's business as usual. And now that the rain has, stopped, hopefully for a little bit, we will go back to our weekly monitoring. And that's all I have.
Great, thank you, Sabrina. Anyone else from the San Francisco Bay Area that would want to provide an update? If not, we'll move on to Region 5, Central Valley region area.
Or Region 4, maybe.
Or we could do Region 4. Let's do Region. I'll move inland. All right.
Is that okay?
That's fine. Yeah, Emily, if you want to give an update on Region 4, let's go for it.
Just to go in order. Let's see. I will share my screen. I have hopefully the right. Do you guys see my PowerPoint slides?
Yes.
Okay, cool. And thanks to Jamie, I have some cool visuals, and then to report on our research projects that I've been doing and working on with her at SCWRP. And then I also just have some verbal updates. But currently we have a region-wide assessment of 17 lakes that we're wrapping up. And I have a draft final report that I'm reviewing. And so that project was to assess kind of the smaller lakes in our urban setting in the LA region. And so initially we looked at 17 lakes and did sampling just to see what's there. And then using that data, we focused in 2021 on 3 lakes to do a season-wide or a season-long monitoring. So we had Machado, Leg Lake, and Lake Piru. And then after that study, or while we're wrapping up that study, we decided, okay, especially after all the red tides and all of the kind of coastal HAB issues, we thought it would be a great time to transition into looking at our coastal water bodies in Region 4. And so we're going to plan that kind of in conjunction with BITE 2023 regional monitoring that's kicking off. And we'll also be able to look at shellfish and kind of hopefully inform and improve our understanding of what's going on the coast. So next, just to give you an idea geographically, the 17 recreational lakes that were surveyed pre and post Labor Day in 2020 are on this map. There's a little call out box for El Dorado Lakes in Long Beach. It's like one large park, and all of the lakes are connected. So all of these lakes were sampled for cyanobacteria, chlorophyll A, cyanotoxins, using water samples and spat bags, and then microcystin genes. And then we were able to get nutrient data as well, total nitrogen, total phosphorus, to try and have a more complete picture of what's going on in the water bodies. And so interestingly, all of the water bodies had the microcystin gene present, and then 88% of the lakes had the microcystin producing genera producing taxa, and then about approximately 53% of the lakes had microcystin either in the water samples or in the spat samplers. And so this was just like a summary, a nice summary of all of the 17 lakes that we were able to look at. Most of them have not been sampled on a regular basis because they're pretty small urban water bodies. And so we decided to try and focus on 3 in the next season, as I mentioned previously, and get a better idea of what was going on kind of on a more in-depth analysis. And so you can see on the figure on the right that the spat samplers really picked up kind of that temporal microcystin. And even though we found it in grab, microcystin was found in grab samples, the spats really kind of give you that cumulative idea of what's going on. Like Piru has some microcystin, but it's definitely not the worst offender. So just good to know and kind of have on the back burner. But Leg Lake and Machado Lake do have TMDLs. And so we were able to work with the city parks on Machado and Leg and, you know, kind of bring some of this to light for them. And they were able to post warnings thanks to the sampling that was done. Typically in our region, we don't get too many incident responses. Our larger water bodies like Pyramid, you can see like up in the top, and Castaic are typically where we see our blooms. And those are also sampled as part of Becky's work. And so those are always on our radar, but a lot of the smaller water bodies don't have as much reporting. And El Dorado Lakes this year was like the other park that I had an incident response. And so we were able to work with park staff. We had a wildlife, so there was like duck deaths there, but I'm pretty sure they determined it was not HABs related. So mostly we're working on research and there's a little bit of incident response. And yeah, that's all I have.
Awesome. Thank
Thanks.
you. Yeah, thanks, Emily.
Thanks.
So Karen, if you want to go for Region 5, and then I just wanted to ask, it looks like I don't have anyone on from Region 3. I realized we skipped over kind of Central Coast. But if
Jamie, I can give an update on that one because I'm going to update for Region 8 too. So
awesome. Okay. All right.
Yeah.
We'll go ahead and we'll do Region 3 after we do Region 5. But
Okay.
go
Sounds
for it.
good. All right. This is my first time trying to share on this computer, so please have some patience while I figure out how this works. Can you guys see? You good?
Looks good.
All right, thank you. Okay, so yep, as Marissa previously mentioned, I'm Karen Atkins, but I am now the FAB coordinator for CDFW. Previously, I was the coordinator for Region 5. I just switched over this week, so I figured I'd just give this quick presentation to you all. So as you can see here, those orange dots on the map on the right are where we had reports of blooms this year. So lots of reports kind of spread throughout the region, primarily though kind of in the central band there. We had danger advisories at quite a few locations. Some of the bigger ones I listed here: Clear Lake, Eastman and Hensley, Big Break Regional Shoreline, San Luis Reservoir had a one that had to do with drinking water as well, so that was kind of a big one. And then Stockton Waterfront as well had danger. These are places that we often see danger advisories, so it wasn't a big surprise. We did lots of pre-holiday assessment sampling this year. Here are some of the locations listed that we had sampling. Some exciting ones were Devil's Postpile, where we hadn't had sampling previously. That's the San Joaquin River up there, right on the boundary of our region. And then we also had lots of Sacramento area ponds, just kind of the county or city ponds sampled as well, as some of the big reservoirs as well. So big shout out, thank you to all of our partners. As you can see, some of our partners listed here, we had lots of different types of partners, all the way from nonprofit to businesses to various tribes to county, state, and even city partners. So that was really cool to see kind of the diversity and people participating. And then we had lots of partner monitoring this year. We kind of had some new partners. So one of them was Restore the Delta. They monitored 7 sites near Stockton weekly for 5 months. So that's a ton of time that they put in. They did weekly, they were doing those test strips. And then we also had monthly, we were able to send in lab samples, and they mostly, it's the Bay, so it's a lot of microcystis there. Then also California State Parks did the North Fork American River and some of the reservoirs on the North Fork as well. They had 4 sites, but we added a couple in based on incident response that we also had. So they kind of expanded that a little bit through time and changed where those sites are. And they did every other week for 4 months. And as you can see on the bottom here, they did do lab testing for cyanotoxins and taxonomy. And we had, a couple different types of blooms going on. We had planktonic and benthic, depending on if it was, in a reservoir or in a river that they were monitoring. And we had Microcoleus, Anabina, Aphamazonemon, and Dolichospermum. So quite the range. And then we also had a big event this year, lots of reports in Tulare County. And so in response, they really quickly put together a partner monitoring program, which is really, really awesome. They were great to work with. And they ended up doing Kaweah River monitoring as well as Kaweah Lake near Three Rivers area. They had 4 sites that they were doing every week for about 4 months. And that was just a visual monitoring program as they were kind of getting their feet wet there. But hopefully next year we'll get to do a little bit more of an in-depth program with them. We also had some special studies going this year. Eastman and Hensley Lake, we were kind of trying to figure out the frequency and severity there and why those 2 lakes bloom differently, even though they have seemingly similar conditions. So there we had lots of different types of monitoring going on, nutrient, eDNA, water quality, and then cyanotoxin monitoring, as well as some species monitoring, taxonomy. So you can see that there were some similarities between Eastman and Hensley. That's a good mashup. So primarily we had microcystis at both, but you can see that there was a Aphamazonemon at Eastman Lake, and Hensley had a little bit of a different makeup when you look at the different species there. And then we also had a Delta microcystis source tracking study. And so we got lots of data on chlorophyll and nutrients, water quality, and cyanotoxin monitoring as well from that study. You guys asked us to talk about mitigation. I talked a little bit about this last year as well. We don't track mitigation measures as part of our program, but this year we did hear about a couple instances of people trying to do some hydrogen peroxide applications, and as well as small algicide type things, mostly on really small lakes. We also started referring people to the CCHAB mitigation subcommittee, mostly just small lakes that kind of were falling through the gaps in terms of, they're an HOA, we can't really help them because they're not having a lot of public exposure, but we did have somewhere to send them this year, which was really cool. And the CCHAB mitigation subcommittee can give their own little update on what they did, but they took on some of these cases, which was really, really cool. And so next steps, since I've moved on, they need to hire a new FHAB coordinator for Region 5. So look out for that if you're interested in a new position. In addition to that, I did put in some partner monitoring and special study proposals before I left. So we are definitely going to have more Stockton partner monitoring going on. But I also am hoping to get some other projects going on. One of them to continue and do kind of some spat bags in Tulare County, and also to continue some of that state parks monitoring. So we'll see what ends up panning out as funding is limited. Thank you. That's all for me.
Great. Thank you so much, Karen. All right. Anyone else from the Region 5 area want to provide an update before we move on to Region 3? Hey, Sarah.
I'd like to provide for Clear Lake.
Awesome.
And let me share my screen. So we do a signage tracker of the different toxin levels at our sites on Clear Lake. And this is basically kind of the summer sampling. And of course, it's based on the values that are recommended for caution, warning, and danger. This is it's neat to kind of see a snapshot of our sites like this. And these are our most common monitoring locations. So we did, and we share this with the county during the summer. We have meetings, I think, every 2 weeks, and they will go out, or the two cities will go out and update the signage and the sampling locations based on the lab results that are identifying the signage recommended. In terms of toxin results, this is kind of a really busy table, but we were monitoring for microcystin and anatoxin. If it made sense to monitor for anatoxin, we do microscopy in-house, and if it's an anatoxin producer, and we're seeing kind of some other things, we'll also analyze for anatoxin. This year, the levels, the microcystin levels were a lot lower than they were the previous year. Matter of fact, the highest toxin level was in the Oaks Arm, which is a part of the lake at Elam Indian Colony, and it was 636. I'm sorry, here it is. Right here, sulfur bait mercury mine, and that it was 790 micrograms per liter for microcystin, a lot lower than 2021 when it was over 160,000 micrograms per liter. We've also noted that the highest levels of toxins, because we also identify the highest level for that location, but the highest level of toxins were happening for each of the sites, mostly in August this year. And then in terms of microscopy, this is also super busy, but we were seeing a lot of Lingvia kind of early on in the, or kind of in the heat of the season. And by the time that microcystis really started to dominate later in the season, the toxin levels we were seeing were just not that high compared to previous years. We also have a creek sampling program that we just got started this year that's funded out of our CalWatch program, which is primarily drinking water, like private system drinking water related. So we identified some creeks within Lake County, and for 2022 did grab samples and spat bags at different locations. We are working on integrating that data so that it's being updated regularly with the other outreach that we do. But we did see, all 4 toxins, saxitoxin, anatoxin, swinner's formopsin, and microcystin in various locations. And we don't really have a way to read that in terms of spat bag results, but we're really glad that Region 1 did such a good study on theirs, so we'll be taking some pointers from them. We do also have a new website. Well, I'm sorry, it's the same website, but kind of new stuff on it, which is basically using a Google map to link all of our sites. We've got some pictures at each of the sites, and we're at most of the sites, and then you can see, so this is bvrancheria.com/Clear Lake cyanotoxins. So it'll have, it also has links to the state's website in terms of reporting blooms and just other things that are on there. So take a look at that. It just automates it a little bit more for us. And that's it. Thank you.
Great. Thank you, Sarah. All right. So I think, Carly, you said you were going to provide an update for Region 3.
Yeah, and I'm just going to do it verbally. Sarah, your site looks great. And actually, speaking of which, I just wanted to highlight that our site now has been updated with the 2023 data. So big shout out to our coordinators for updating a lot of the data to make sure we could transfer it over to this year, because that was a big lift. So we're now current on our map as well. My name is Carly Nelson, by the way. I work alongside Marissa Van Dyke at the State Water Board and the FHAB program, and I'm giving an update for Melissa Daughtery from Region 3, and that's the San Luis Obispo office, and they were pretty busy this summer with the holiday assessment. They did up to 15 sites every assessment, and they were really lucky to have some awesome volunteers up in the Santa Cruz area to help with that. I want to highlight some of the areas. So they did Monterey, Lake Nacimiento, San Antonio, Santa Margarita, Oso Flaco Lake and Creek, and Lopez and Laguna Lakes. I want to highlight that Santa Margarita and Monterey Wharf, actually, for that matter, they stayed in the caution level until late October, which is pretty unique. And Pinto Lake was still at a danger in the end of this year. the last time they sampled. So that's the quick update for them.
All right, so let's go east a little bit. And I know region 6 has an update. So if the Lahontan region wants to give their update, you should be able to share. Awesome.
Good morning, everyone. Trying to share my screen here. Okay. Can you see the slides? I think it just switched screens.
Yeah, I can see. Looks good.
Did it go into the presenter mode?
It is, yeah.
Okay, perfect. So I just have a pretty brief update, but I'm the harmful algal bloom coordinator for Region 6. And so we had, here's just our number of advisories in our region. So we had 15 caution advisories, and this was just the highest tier from each water body throughout the season. 1 warning and then 6 danger advisories. And I put these all on a map, and I apologize, the image got a little grainy here, but you can at least kind of visualize where these water bodies are. So we had, I just wanted to point out that the danger advisories, we had it in the Tahoe Keys Lagoons, Indian Creek Reservoir, Bridgeport Reservoir, and then I have the bottom part of our region on this map, Crowley Lake, Pleasant Valley Reservoir, and then Quail Lake. We had 1 warning at Silverwood Lake down here. And then I just, put some photos together for some of the danger advisories. They definitely happened later on in the season. And I have, the only photo I don't have is from Quail Lake for the dangers. And for the kinds of monitoring we did, we, assessed new and recurring blooms. We did incident response. I somehow forgot to put, we participated in the pre-holiday assessments this year, which we have been trying to expand each year. And just kind of to put a plug in here, if anyone's interested in participating in our region in the pre-holiday assessments, please feel free to reach out to me. And then we continued our special studies. So we have a special study going on in the Tahoe Keys to evaluate the effectiveness of a non-chemical control measure on blooms, and that's a laminar flow aeration system. And then we also sample some high elevation lakes to hopefully develop some risk criteria to help predict HABs in the future. And all of this monitoring would not happen without all our great partners. So thank you all if any of you are on the call. And again, if you're interested in monitoring some water bodies, please reach out. And that's my update.
Great, thank you, Sabrina. I appreciate that. Anyone else in the Lahontan region that wants to provide updates? All right. So we are moving south. Let's go ahead and move back to the coast. And Carly, sorry to play popcorn with you. You said you were going to provide an update for region 8. We'll do 8 and then 9, and then we'll end with 7 and anyone else who wants to provide updates.
Okay, sorry guys, I was just reorienting myself. Can everyone see the screen?
Yes, we can see it.
Cool. So I'm presenting for Region 8, the Santa Ana region. Unfortunately, they weren't able to make it today, but they did some pretty exciting stuff this year and last year in terms of special studies they wanted me to share with you all. So first, I'm just going to share a little bit about Lake Elsinore. As many of you guys know, it has blooms year round. And they haven't had an opportunity at the regional board to really sample on a regular basis to understand the status and trends. So they started looking at it every 2 weeks from May of 2021 to November of 2022. And they focused on 2 sites, one in the mid-lake and one on the shoreline. And those are actually designated TMDL sampling locations. And they're pretty representative because the lake is well mixed. The next slide, I just want to highlight that they sampled for just more than toxins. So they looked at quite a few parameters, as you can see here. Also looking at some nutrients and things of that nature. This next site is just highlighting where those sampling locations are. They're where the orange stars are. So as you can see, one is in the mid-lake and then one is on the shoreline. And these are some of their preliminary results. So they highlighted here the danger level because some of the samples actually went quite above the danger threshold. So it's just to highlight that for the most part, there was a pretty big jump, especially in 2022 in the summertime. And looking at that more in a bar graph, they put this together just so you could kind of look at the different trigger levels. The one thing I really want to highlight is the yellow, that's the caution. And with the CCHAB guidance, that's triggered by any of the visual observations. So they did observe a bloom 100% of the time, which is why that's at 100%. And then with the actual toxin results, this is what's triggered then the warning and the danger. So they're still finishing up some of that data analysis, and I'm sure they'll probably share something a little more comprehensive with the group when they have a chance, but they're still sort of in that preliminary data evaluation at this point. The other special study they did was at Big Bear Lake, and this one's a little bit different. They sampled less frequently, but had quite a few more sites. So they did once a month from May to November, and they looked from May 2021 to November 2022. And they focused on 6 to 7 sites across the lake. And these slides show that pretty well. So in 2021, they had these 6 sites, and they're pretty well spatially represented. In 2022, oh wait, no, I did have it right, sorry. They added the dam site right here. So that was the big difference, is they just added one more site. And some of their preliminary results was that they started to see microcystins in May, but it was below the caution level. In June, it got heightened to the caution level. And then in July, some sites to the east side of the lake were at the warning level. In August, which was not great, most of the sites were above the danger level. And then through September and November, it sort of equalized and kind of came down with the cooling temperatures. But microcystin was still observed at the caution level. And here's just a graph or bar graph showing some of their results. As you can see, like, these are the sites across the whole lake. So it was pretty transparent that the bloom wasn't necessarily isolated to one part of the lake. It definitely was persistent in a lot of different areas, concentrated in some areas more than others, but it definitely was an issue. And they did sample at quite a few of the high recreation areas. So it was really great because they were able to get a lot of signage out this summer. And with that, I think that's it for me.
Great. Thank you, Carly. Anyone else from the Region 8 area, the Orange County, Santa Ana area? If not, we'll go ahead and move down to Region 9. I know you guys have an update, Carrie. If
yeah, let me see if I can get this. Okay.
Perfect.
All right, is that in the, okay, can you see presenter mode now?
We can, yes.
Okay, perfect. So, okay, so San Diego region, we experienced blooms in a variety of habitat types this past year. So I just wanted to highlight some of our more notable blooms. So that included one in an estuary, 2 different rivers, and 3 lakes. And the monitoring that we conducted included taking sonde readings of temperature, pH, DO, specific conductivity, and then we took grab samples at all sites for species ID and toxin analyses. And then some of those we also took grabs for the toxin genes. And this was a mix of incident response and our pre-holiday work this past year. So our one major estuary bloom was in the San Luis Rey River estuary during the summertime. And that's where we had many mats of Lingbia spread throughout the estuary. It was posted for a caution level, and that was mostly due to anatoxin A. but we did find some other toxins at lower levels in our grab samples. It was eventually washed out by the rain and wave action, and there was a little bit of regrowth, but as the rains continued, it eventually flushed out. And I'm happy to say that as of this month, it's still clear. This is a site that we can actually keep a close eye on because we regularly visit for a different monitoring project for beach bacteria monitoring. So the one good thing, this was a new site for Bloom for us this year, but we were able to work with the lifeguards really well, and they promptly posted the caution signs for us. So that was kind of a nice new little partnership that we developed. And even though the lifeguards let us know that dogs aren't supposed to be going in the estuary, but most of the times, especially during the nicer weather, we see dogs and kids playing in the estuary pretty much each time we're there. So, and I know Jamie had asked about the beneficial uses affected. So this one obviously would be the recreational and wildlife beneficial uses that were affected. So our most toxic bloom this year occurred at Cedar Creek at the falls. And this is a really popular hiking destination where people do often bring their dogs as well. This was a site that was included in our pre-holiday assessments. And it wasn't actually in bloom during Memorial Day or the 4th of July holiday assessments, but we did observe a small amount of microcystis in the samples. So we were guessing that a bloom was soon to come, especially as the weather was getting hotter. So what happened here was the trail was actually closed because of extreme heat from mid-July past the Labor Day holiday. So as soon as the trail reopened, we went back for sampling, and it was a lot worse than we actually suspected. So the microcystins were at about 95 micrograms per liter, and we worked with the U.S. Forest Service to get signs posted immediately, and we had messages posted on social media. So we've gone back after several rain events, and the microcystin concentrations are lower, but they're still at a danger level. So we're waiting for these latest rain events, and we're planning to sample again on February 1st. So hopefully we'll be able to close this one out then, but we'll see what happens. And let's see, our other riverine bloom occurred in the San Dieguito River, and this was at the Arroyo Preserve, where people hike along the river and bring their dogs here as well. And we were notified of this bloom after a concerned citizen had visited with her dog. Her dog had gotten into the water a little bit and had licked her paws and drank some, but thankfully the dog was fine. So we went out and collected samples, and we did see it was caution posted because there was a bloom present. We did find Dolichospermum in the earlier samples, and then later when we went back, we did see some Lyngbia as well. There were just very low levels of saxitoxin, though, thankfully, detected in the toxin samples. And so the property owner, which is Rancho Santa Fe Association, they post signs until the bloom dissipated. And we did conduct the follow-up sampling after it dissipated to ensure that there were no more toxins. And this is another potential good partner for us because the association had reached out for additional information so that they can do their own sampling in the future. So that would be great if they get that going. Let's see, so Lake Henshaw, which has pretty much been our region's problem child for years now, was in bloom from January through August with fluctuating toxin concentrations. I know the graphic is kind of small, but just to show the fluctuations. And it's usually microcystins and then sometimes anatoxin A that are detected there. So this year they treated the lake in August, and at that time we stopped getting satellite notifications for a little bit, and the toxin levels dropped. So Vista Irrigation District is the manager of this lake, and they do weekly sampling, and they share their lab reports with us. So we always know what's happening there. So since that treatment in August, the toxins have been low or non-detect with just a small little blip in October, but even though the toxin levels aren't threatening, they do keep caution signs posted year round there, and they have not been releasing water downstream to the reservoir. It's Lake Wolford that's used for drinking water. So they've been working with a consultant for remediation actions for about 2 years now, which include lake and tributary treatments and some actual just vascular plant removal too in some of the tributaries. Let's see, our other reservoir that had satellite notifications that we went to this year is Lower Otay Reservoir. And we received notifications from January through February, but at that time we were actually restricted from doing some field work for COVID. So as soon as those were restricted, we went out and we worked with the lake manager to collect samples. And toxins were not detected at that time, but some of the species were identified in the grab sample because the bloom was pretty much on its way out by the time we got there. But thankfully, the reservoir managers were very aware and they had already altered the operations accordingly. So that meant more Colorado River water was being treated for drinking water versus pulling water from Otay Reservoir for the local drinking water plant right there. And then I will finish with our most exciting and interesting bloom, perhaps of the year, happened at Choya's Lake. And so here we received a complaint of a potential spill where somebody allegedly said that they had possibly seen a government truck dumping something into the lake. So, so this report it was routed through our compliance staff, but eventually it was rerouted to us because of these amazing photos that were attached to the report of its kind of a beautiful golden bloom. So, you know, they were thinking possibly cyanobacteria. So by the time we got out, there had been some rains and it wasn't nearly as large, but there was still that streaking that you typically would associate with a cyanobloom, and there were rings around the edges of the lake. However, good news, no evidence of wildlife impacts were reported. And when we were out, we saw lots of fish and waterfowl that appeared to be fine. So we took a sample first and looked at it under the scope, but couldn't quite figure out what it was since it didn't look like any of the cyanobacteria that we were familiar with. So we ended up sharing some of the sample with Rosalina at Cal State San Marcos. I'm sure a lot of you know of her. And she was able to identify it as the green alga Botryococcus. So my main point for sharing this was just to, in case you see it in your region, so you don't go through the same mystery that we did. And this is only the second time that Botryococcus was reported in our region, once in 2017 in a stream that's downstream of our Lake Cuyamaca. So I think that is it.
Awesome. Thank you
Stop
so much.
sharing.
Yeah, that was awesome. Okay. So is there anyone from Region 7 on that would want to provide an update?
If Jeff's not on, I can do it quickly.
Yeah, I don't see him on. So
Okay. I don't want to have him be messed because he's done a lot this year. Once again, hi, Carly. I'm going to be giving the update, I guess, for the Colorado River region, which is Jeff Geraci, who's the FHAB coordinator there. And they did some monitoring on the Salton Sea. It continued to have some mixed blooms this summer. And then for the holiday assessment, they actually partnered with their county representatives. So they did Weist and Sunbeam Lake, and they both had advisories throughout most of the season, and they were awesome to work with, and they posted really rapidly. And it was the first time I think that they've really monitored there. So they're kind of getting their feet wet as well, and hopefully they'll participate next year. And perhaps we can add on some more lakes. But something awesome to highlight that Jeff undertook late this fall is he actually started sort of an impromptu monitoring program on Lake Havasu. And he did a lot of collaboration working out like with the Fish and Wildlife folks and some of the researchers there with the University of Arizona, and was able to get out a few times on a boat and do some shoreline monitoring, which was actually a little bit more challenging because there wasn't as many areas to access. But I think he collected like 20 to 30 samples every sampling event. And it's one of the first times that Lake Havasu has actually had any monitoring really for cyanobacteria and cyanotoxins. So it was interesting to note that there were quite a few danger advisories in a lot of those coves. And it really just begs the fact that a more routine monitoring program should probably be in place there. And so I think he's been kind of working diligently in the off season to try to work with some of the partners in Arizona and see how we can further develop a program there. And that's it for Region 7.
Awesome. Okay, so I think that completes all we have a couple minutes. I have Randy Turner from SFEI was interested in providing an update. And then I don't know if there's send me a message if there's anyone else on the line that wanted to provide an update. But Randy, if you want to go for it.
Yeah, thanks, Jamie. I just wanted to give people an update of our satellite analysis tool. Most of you have probably been to it, but we have a few things in process. We're currently building an application programming interface to help people retrieve data, kind of using code and script. So that might be helpful to folks. That's coming soon. And then perhaps most importantly, we're in the process of adding chlorophyll A data from the same Sentinel-3 satellite that we currently have the cyanobacteria index data for. So that's something we expect to be released by this spring, by kind of the start of the bloom season. And so that will be, I think, really good to help complement the cyanobacteria data that we currently display. Just to really get a good understanding of primary production in general in the large lakes of California that we cover. We're also working with Jamie and Squirt's Remote Sensing Technical Advisory Committee, partly to get input from folks on this call today about what could make our FHAB tool more helpful in terms of additional data, different ways to analyze the data, different graphs to present. Just what would be most helpful to you is really kind of our request and our question. So if there's ways that you use our tool that you wish there was a slightly different way to look at the data or visualize it or download it, we're looking for input from the TAC as well as you directly. So feel free to reach out if you have any ideas or questions or thoughts. And then I'll put my contact info in the chat.
Awesome. Thank you so much, Randy. All right. So I think unless anyone else on the line has some monitoring updates, that would conclude this section and we'll just go into a break. So is there anyone else? All right. All right, so on the agenda, we are going to take a quick break and then we will come back and do our portion of the meeting where we're going to do kind of a crossover event of 2023 with the molecular work group and kind of have a combination of, we'll hear from Susie Thoreau, who is the chair of the molecular work group, to kind of talk about what they do and the collaborations that are possible between their group and ours. And then we'll hear a series of research talks kind of demonstrating the use of molecular approaches for assessment of HABs. So I'd say let's go ahead and plan to come back at 10:30, but we'll give everyone a quick break to grab a snack, grab a glass of water, and we'll see you at 10:30. All right, we're just gonna get started in a second here. So I think Susie should be online. Susie, if you want to start getting your screen up, then we'll be ready to go. Well, it's 10:30 now, but we can get rolling. Awesome.
Okay, hopefully you can see that.
Yes,
Perfect.
still in slide sorter mode.
There we go. How's that?
Perfect.
Good. Okay.
All right. So thank you, everybody, for a great set of updates this morning about all the monitoring that's happening statewide. So we're back and we're kind of entering our molecular approaches to assessing HABs section. So I'm really excited to introduce my colleague Susie Thoreau. She is the chair of the California Molecular Work Group. And so they do a wide variety of, eDNA or molecular approach topics. And I don't want to steal her thunder too much, but, one of the things that her group has been really interested in the last several meetings, they've had some HAB-centric talks And so the co-chairs all thought it would be a great opportunity to kind of get these groups talking together. And so without any further ado, Susie, if you want to kind of take it away and talk about kind of what the group's doing. And then we have a fun set of research talks to follow.
Awesome. Thanks, Jamie. It's so great to be here. I really loved hearing about all the great work that's being done across the state earlier this morning. And so my goals today are really to give you a brief overview of our aims and what we do at the California Molecular Methods Work Group, and then identify some of the ways that I think we could have even greater collaboration between these two work groups. So how CCHAB and the Molecular Methods Work Group can really be identifying key areas of overlap of interest, and build some new partnerships or strengthen some existing collaborations moving forward to help us both achieve our goals. With that, I thought it would be helpful to just kind of set the stage and think about like how quickly we're seeing the incorporation of different DNA or RNA based technologies, or what we like to just call the bucket of molecular methods that we have in our toolkits and at our disposal. So this is just a quick snapshot that shows you, the increase in publications that we've seen in recent years that have incorporated a molecular element or eDNA sampling into routine or event response HAB sampling. And so I think we're seeing that same thing occurring here in California, where increasingly we're incorporating these different molecular methods into our routine sampling events. And I think it's important to also be thinking about what are some of the key motivations and what are DNA methods bringing to the table that we didn't have access to before, and how can we make sure that how we're collecting those samples and analyzing those samples has some amount of agreement among all of our different approaches, so that all the great data that we're collecting across the state can really begin to be compared to each other. All right, there's this great review paper that came out last year by Feist and Lance, where they were highlighting some of these key applications. So if you're someone that is maybe eDNA curious, or you haven't been working with some of these molecular methods yet yourself, this just provides kind of a brief overview of what some of the different technologies are that we've been adopting into our toolkits. So probably most of us are familiar at this point with qPCR, thank you COVID, and then its cousin digital PCR, and these are both great applications if you have specific species or specific genes that you want to quantify from your samples. Oftentimes we're targeting specific toxin-producing taxa, or as we had heard about earlier today, potentially toxin biosynthetic pathways, gene pathways, so genes within those pathways, and we can begin to quantify the abundance of those gene targets in your sample. In contrast, we have DNA metabarcode sequencing, which really gives us a great comprehensive snapshot of the different species that are present in a sample. So we might look specifically for cyanobacteria taxa to get a sense of the breadth of diversity of different cyanohabs that might be present in our samples. I would say those are the two most popular approaches that we're often seeing incorporated into monitoring campaigns that have a HABs angle. And then now kind of emerging on the market as well are some of these isothermal applications. So these are definitely like an emerging technology. We don't see wide scale adoption of these just yet, but they have the potential to be really, really helpful because they can provide really rapid, really specific, so species specific or gene specific assays, and they can be deployed into the field. Think of something similar to like a pH dipstick. And so the more that there are really specific research questions that could be hopefully addressed with in-field rapid answers, we'll see greater adoption of these sorts of isothermal type of applications. So that's just a quick overview of the types of tools that we have in our toolkits for HABs monitoring. Talking about how some of these molecular methods have been incorporated into different monitoring programs so far in California. Two quick examples. So one set of DNA samples that we collected over the course of a couple of months throughout the summer and fall in Lake Elsinore in 2016 captured a really robust bloom event that happened. And so the figure that you have here on your left is just showing relative abundance of different cyanobacteria species that we identified using DNA metabarcode sequencing from these Lake Elsinore water samples. And we could see this shift from a Planktothrix dominated community to a Microcystis dominated community. We also had paired those DNA samples with microscopy data. And what was really nice was we saw correspondence between those two different lines of evidence. And we also likewise saw that increase in the Microcystis community as we got later into the season. And so this was just a really nice way to kind of begin introducing DNA as like an additional line of evidence into some of these different monitoring programs. As Emily had mentioned before, now we're working on a series of lakes in Region 4, where we've been doing DNA metabarcode sequencing for cyanobacteria community composition, and then likewise pairing that with a digital PCR approach where we're looking specifically for the MCYE genes and seeing how we can gauge the presence of some of these potential gene biosynthetic pathways, and that would be producing microcysteines, and then comparing that to the community composition and the shifts over time. So that's just a quick overview of how you can begin incorporating some of these different molecular methods into research programs to give us some new information that maybe we didn't have access to before. Okie doke. So with that being said, as we're beginning to introduce these molecular methods into a number of different monitoring programs, oftentimes when you're getting started, you have questions along the lines of, okay, where should I be collecting my sample? Or how should I be filtering it or concentrating it? How should I be preserving it? Should it be frozen? Should I have some sort of preservative added to it? When I'm doing my extraction, should I be using a kit? Should I be doing something that I'm designing myself? What sort of internal positive control should I be using? What primer should I be using for sequencing? There's just a ton of questions that you're faced with when you're designing some of these new sampling programs that are incorporating a new novel molecular method that maybe you haven't included before. Some of these questions will be really specific to the research questions that you're interested in answering. Of course, something like which DNA sequencing primers you might want to be using, or which qPCR assay you might want to be using could be really specific to your environment or the taxa that you suspect might be present, versus if you don't have a real sense of who might be there, if you want to do more broad scale biodiversity types of questions that you're looking to answer. So in general, there's just, it would be really great if we had some sort of centralized resource that was helping you answer some of these questions, maybe some sort of decision tree that's helping guide these decisions as you're designing one of these new sampling programs. And so in 2018, in discussions with the California Water Quality Monitoring Council, we realized that there was a need here for a centralized group that could begin to provide resources to help guide these, answering some of these questions when designing these different types of surveys. So the California Molecular Methods Work Group was formed to be a clearinghouse for DNA method development and provide a forum for researchers and stakeholders across the state to come together and really ask questions about survey design and different sampling and analytical approaches and data interpretation, and also talk about some of the fun stuff. So some of these new technologies that are coming online, how can they be incorporated into my sampling campaigns, or what sorts of problems am I encountering and with DNA reference libraries, and I can't find my reference sequences that I need. The Molecular Methods Work Group really serves to be a community and a forum where folks can come together and discuss those different elements of building in about DNA methods into a monitoring campaign. Okay, so as I said, in 2018, the California Water Quality Monitoring Council officially put a stamp of approval on forming the California Molecular Methods Work Group. And we had three key goals that we kind of laid out, which were to draft standard operating procedures for monitoring programs for future implementation, interface the stakeholder and practitioner community to review protocol design and feasibility, and then also help to coordinate pilot studies and intercalibration exercises, as well as training events. And so we've tried to do a little bit of that over the past now 4, almost 5 years. And any successes that we've had have really been because we have such a broad, diverse community represented in the Molecular Methods Work Group. So I just have like a couple of the logos shown here. We have a number of different staff from various regional boards. We have a bunch of folks from universities or different research institutions, not only in California, but even internationally, that join our Molecular Methods Work Group. Because if you're working in eDNA, you want to be able to, bounce ideas off of other folks, of course. And so we tend to bring in even a wider breadth than just folks here in California, focus on samples that are collected here, but it's just been a really great way to kind of broaden our scope. We also have folks that are in stakeholder communities or those who anticipate adopting eDNA methods in the future, even if they haven't done so yet. We have environmental consulting firms who are present, who I think envision or are already collecting these eDNA samples. And so it's just a really broad, diverse community. And I think that really just strengthens all of the products that we are creating because we have a lot of input from a lot of different potential user communities. And that's just helped shine a light on some of the types of needs or wants that are specific to each of those different kinds of user communities. So it is open to anyone. And so I always put out a call if you want to join. Of course, please just like shoot me an email. We meet monthly and everyone's welcome. Right now we have over 200 members. And as I was just saying, it is a really, a potpourri of different types of users, whether they're technical experts from the regulatory community or stakeholder groups, and then even the broader community reaching out across the state and beyond. Talking about some of the different protocols that we have so far developed, there are 3 in particular that I want to highlight. We like to call these kind of best practice documents because there's always this balance between how prescriptive you're going to be in a standardized protocol, and if that kind of excludes some potential users because you've gotten too into the nitty-gritty detail. So oftentimes we try to stay at the higher level where this is like best practices that can then be tailored to different monitoring programs and their specific needs. But we really try and highlight all of the different elements that need to be considered in terms of sterility or replication or incorporation of positive and negative controls and all those various elements. So the 3 protocols that we've drafted so far include a DNA sampling best practices, a DNA sampling protocol for water eDNA, and then metadata reporting standards. This last one, I would say, is almost the most important of all, and it's really the key to having your data be replicable and well annotated, and so that folks know, exactly what sort of volume you filtered onto your filter, what DNA extraction you used, what primers you used for amplification, all of that critical metadata that has to get recorded in order to best interpret any sort of DNA results. So far, we've seen these protocols serve as a template to be adopted into a series of different monitoring programs. The estuary MPA sampling program that's been sampling estuaries up and down California. The Southern California Bight submerged aquatic vegetation sampling, incorporating this methodology also. And then we've been working with the SWAMP program, the CCHAB program on wrapping these eDNA sampling protocols into kind of a SWAMP specific eDNA sampling protocol as well. So that's really the goal for a lot of these protocols, is that they're useful and that they are incorporated into a number of different monitoring campaigns. We have our eyes set on a couple of other standardized protocols that we'd like to be developing also, including sediments and biofilms and a couple of other standardized protocols that we're hoping to put out in the next few years. All right, so as I said, we meet monthly. They are really casual meetings, and we always love having as many people there as possible because it's more lively discussion. We focus on the latest research. We also have people present various resources that they've been using to help aid their DNA collection or interpretation. A couple of snapshots here from some screen grabs, I would say, from some of our recent meetings where I was giving an overview of a new publication that talked about the various state of the field in terms of eDNA sampling in freshwater systems. And then, as Jamie had mentioned last month, we heard from Keith Baumann-Gregson on some of the molecular work that he was doing in San Francisco Bay. And it's just been really great opportunity to hear about new research that people are doing, the different approaches that they're using, and how that can, help inspire other folks in how they're designing their sampling programs or interpreting their data. We also have all the recordings from our meetings are available online on our Google Drive, which you can find by going to the water quality monitoring website. Okay, lastly, as I mentioned, one of the other things we really care about is broadening the user community, which means having some training elements also in some of our activities. So this coming year, we collaborated with the Water Quality Monitoring Council's Monitoring Collaboration Network, and we'll be having a series of about 6 webinars that'll focus on everything from eDNA 101 to eDNA for bioassessment, eDNA for HABs. We're collaborating with a bunch of folks from this group to help design that lecture. eDNA for species surveillance, so this is incorporating it for targeted invasive and endangered species sampling. eDNA for human health, and then data analysis and bioinformatics. So these have yet to be scheduled. We're working on that right now, but then we'll send out an email blast. You'll see on the Lyris about these upcoming training webinars. And so hopefully we'll see some of you there as well. Okay, so one of my big goals for today was to identify some of the ways that I think the Molecular Methods Work Group and CCHAB can really be working together even more. And I would say we have some great existing collaborations between members of CCHAB and members of Molecular Methods Work Group. And I would really love us to find even more ways that the two groups can be working together, leveraging everybody's expertise and interests, and developing some resources that would really help the community at large. So I came up with 4. I'd love to hear from anybody if you have any additional opportunities that you want to add to this list. So my 4 were designing sampling methods and protocols, finding ways that we can more officially align how we're collecting samples, and some of our analytical and interpretation approaches. And so some of those like draft SOPs or protocols that we developed through the Molecular Methods Work Group, I'd love it if one of those was like water eDNA sampling for routine monitoring for HABs or event response for HABs, something along those lines. Also participating in intercalibration exercises. I'll talk a little bit about what some of that might look like. DNA reference library. So this is always a concern for anyone that's taking part of a DNA metabarcoding survey. How complete is my DNA reference library? Do I have all the species represented that I want to have there, to be able to identify them from my samples? And oftentimes we spend a ton of time curating some of these reference libraries. And if we can be collaborating on that effort, having a centralized repository where we could all be pointing our bioinformatics scripts towards, and we could be analyzing our data in similar ways, it'll increase some of the harmony between our different data sets. And then similarly, bioinformatic approaches. So let me just touch on each of these real fast, and to give a little bit more detail. So as I was mentioning, through the Molecular Methods Work Group, we developed these SOPs. And so we have this water eDNA SOP, and I would love to even like further hone it in for what would really serve the HABs community. And so if we could somehow have, you know, seal of approval from the Molecular Methods Work Group and CCHAB community, that this would be a great, like, ready to go off the shelf water eDNA sampling for HABs, either qPCR or digital PCR or DNA metabarcoding approaches. I think that would just be really powerful. Hopefully it helps lower that barrier to implementation for some folks if they feel like, I want to do this, but I don't know how to get started. This would be, we could point them to this immediately, being like, this would be a great, like, ready to go protocol. Here you go. It recommends what type of filter you might want to use, what type of volumes you should be collecting, or replicates, preservation, all that sort of stuff. So if we could have one that represents either the best practices or gives some clear guidance on how that should be performed, I would love it if it was like CCHAB and Molecular Methods Work Group endorsed. Okay, similarly, it's been a long-term goal of mine to do a DNA extraction intercalibration exercise. Oftentimes when you have your DNA sample and you extract it, you might use your favorite DNA extraction kit. And one thing that we often don't know is how any sorts of biases that might get introduced by your favorite different DNA extraction kit. And so if we could do an intercalibration exercise with, you know, common samples that are shared among a bunch of different people, all using their preferred DNA extraction kits, we can begin to identify some of those potential biases. DNA reference libraries. This actually came up in a great discussion when Keith Bauma-Grigson had presented earlier this month. And so he's been using a curated reference library that harnesses this Silva DNA reference database, one of these global DNA reference databases. Different folks have their preferences for which reference databases they like to use. It can have a big impact on some of your outcomes and downstream analyses, depending on how well curated it was, if there were some species that might have been missing or not. And I think if we could be working together and identifying a common reference library, it'll help us, again, harmonize some of the data that we're all generating. Last slide. As I mentioned, similarly, if we could have kind of signed off on some bioinformatic approaches that would, again, be shelf ready, grab and go, that some different user communities could say, again, I'm new to bioinformatics. I don't know if I should be using CHIME, if I should be using Mother, if I should be using some other bioinformatic program. If we had a couple that the Molecular Methods Work Group and CCHAB said, these are good to go, feel free to use them, to tweak them, but they cover your bases, I would love to have that. And I hope it would help accelerate the adoption of some of these methods. So with that, if any of these ideas sound good to you, or you have new ones that you think of, please feel free to reach out to me. I'd love to find more ways for CCHAB and the Molecular Methods Work Group to be developing some of these shared resources so that we could just help accelerate and standardize and harmonize DNA data collected across the state. Thanks, Jamie.
Thank you so much, Susie. I think we'd love to have further conversation. I think we got to move on in our agenda to keep on time, but please, if you want to continue this conversation, shoot an email to Susie and myself, and we can kind of, if we have time at the end of this section, we can have some discussion, or we could even set up a time for, further discussion. But with that, I would love to kind of turn it over to Forrest Leffler. He's going to speak with us about some cyanobacterial diversity work that was part of PhD thesis work. And Forrest is now a postdoc with Dale Loffinghouse at the University of Florida. And so with that, Forrest, you should be able to share your screen. And I'll let you kind of, take it away. So thanks, Forrest.
Right, can you see it? I just want to make sure.
Yeah, we can see
Perfect.
it.
Okay.
You're in slide sorter mode at the moment. If you want to put it in presentation. Perfect.
How's that?
Looks great.
Awesome.
Yeah, go for it.
Okay. All right. Thank you, Jamie. Yeah. So I'm Forrest Leffler. Today I'll be talking to you guys about cyanobacterial diversity in Lake Okeechobee. So let's get into it. I think we all know more or less what cyanobacterial harmful algal blooms are. Dense growth of algae may be capable of producing toxins, as well as taste and odor compounds. These can be benthic blooms, which will form here on the benthos, but as well as planktonic blooms. These can form in several different places in the water column. This is typically what we see in freshwater, but of course there are also benthic blooms. Here in Florida, we're seeing a lot of benthic marine blooms because blooms can be also fresh or marine. But I'm not going to spend too much time here. And they can produce cyanotoxins as well, right? Of course, when we think of cyanotoxins, we think of microcystins, 256 different congeners, microcystin LR being the most common. These are produced by a wide range of cyanobacteria, not just microcystis. But there are several others, just to name a few: nodularins, splendidospermopsins, anatoxins, anatoxin AS, which is now guanotoxin, lingbiatoxin. There are dozens, if not hundreds, of different cyanobacterial toxins. And so what drives these cyanobacterial blooms is mainly two things. Of course, these aren't the only two, but eutrophication and increased temperature. Eutrophication in the sense of increased nitrogen and phosphorus inputs. And of course, there are several different types of ways that you can increase the nitrogen and phosphorus inputs. Fertilizer, both as agricultural and urban. If you're fertilizing your lawn, that can run off, make its way into water bodies. You've now leads to an increase in nitrogen and phosphorus. Sewage and septic tank leakage can also lead to eutrophication. Industrial effluents, livestock, municipal wastewater, and there are dozens, if not hundreds more. And then increased temperatures, as we see the global climate increase in temperature, that provides a competitive advantage to cyanobacteria over other phytoplankton. Once you reach about 30 degrees Celsius, cyanobacteria are able to proliferate, whereas eukaryotic phytoplankton groups are not. They don't like it as hot. But cyanobacterial blooms do like it hot, as made famous by Hans Perl and Jeff Weissman. But I'll be talking to you guys about Lake Okeechobee. This is not in California. This is in Florida. And this is a very large eutrophic shallow subtropical lake in the Florida Peninsula. It's really shallow, has an average depth of about 3 meters, and it only is about 5 meters deep at its deepest point. It has a very large watershed, which extends all the way in the north in Orlando, kind of the Disney World area, and works its way down into Lake Okeechobee. This contributes 70–80% of the water that comes into the lake, and there are some smaller watersheds which contribute much less. But due to this, there's been excessive phosphorus loading into Lake Okeechobee, which has led to a lot of legacy phosphorus, which is bound to the sediments. And so what this actually creates is a nitrogen-limited system within Lake Okeechobee, just due to just the excessive amount of phosphorus that's in there. And I want to show this. This is the drainage basin. This is the land use. So there are several different types of anthropogenic inputs that drain into Lake Okeechobee. Up here in the north, Disney World is going to be right here, and this is Orlando. This is the urban area, so this is where people live. All the theme parks, all the tourist attractions, fun stuff. We have citrus groves where there's going to be fertilizer applications. That's going to be here in the orange. But then there's also ornamental plants that are being grown, sod being grown. There's pastures for livestock. There's also dairies throughout this area. And to the south, what we can see in this area is there's a lot of sugarcane happening here. So lots of agricultural, lots of livestock, lots of urban areas. So several different types of anthropogenic impacts, which run off and make their way into Lake Okeechobee. And so this creates a very eutrophic area. And so there are lots of cyanobacterial blooms that happen in Lake Okeechobee. I think the two most famous, if you will, cases are going to be in 2016 and 2018, where there were large microcystis blooms. Both of these led to a state of emergency being declared in the state of Florida due to the excessive amount of cyanotoxins that were being produced, as well as just the coverage. This is from the Copernicus and Sentinel satellites. This was the 2018 bloom at its maximum, which covered about 90% of the lake surface. And there were very high concentrations of microcystins found throughout the lake as well. But we don't just have microcystis blooms in the lake. There's also dolichosperma blooms at a much lower scale. However, back in the 1970s, 1980s, there were dolichospermum, formerly known as anabina blooms that occurred in the lake. We still see them to a lesser extent, but again, nothing like the microcystis blooms which we're having now. So if you're not familiar with what microcystis looks like, this is going to be microcystis over here, and this is dolichospermum here. And this is the 2018 bloom that occurred, the microcystis dominated one. And what I want to point out here is when we think of these blooms, often they're thought of as monospecific blooms. So we have a microcystis bloom, maybe a microcystis aeruginosa bloom. But when we gather these blooms and we observe them under the microscope, we see several different morphospecies of microcystis occurring. So you can have microcystis aeruginosa, Weissenbergii, paniformis, and you can see here, and each of these are potentially producing different types of toxins, potentially producing the same toxins or no toxins at all. So we can see here too, 2, maybe 3 different morphospecies. And the same thing with dolichospermum. These are constantly attributed to Dolichospermum circinale, but we can see here there's at least 3 different morphospecies or 3 species, depending on who you ask with Dolichospermum. So the blooms that we have here are not monospecific. These can be very complex communities. And these blooms form a complex relationship with bacteria. It's not just bacteria, protists, other photosynthetic algal groups, viruses, fungi. I'm sure I'm missing several other things, but the bacteria is what I want to focus on here, because these colonies, these microcystis colonies, are covered in bacteria, and you can see some potentially bacterial cells up in this area. And this is really important. This is not very well understood. We're really just starting to scratch the surface of these communities and how they interact with each other. But when we look at the functional roles of microcystis, we see that, of course, they're capable of photosynthesis, carbon fixation, and a few other things. But when we look at the functional roles of the bacteria, we see that they are capable of much more nutrient pathways, such as nitrogen cycling. So these are capable of fixing nitrogen, denitrification, urea cycling, sulfur cycling. It never made its way into this graphic, but also phosphorus cycling, etc. So these form complex communities which interact with each other, and this bacteria can help potentially help these blooms proliferate. And this is a complicated graphing showing just the complicated nature of these pathways, where you're going to have these green lines, which are exclusive to microcystis, and these yellow lines, which are exclusive to the bacteria. And we can see that these are intertwined and exclusive to one or the other. Just a complicated graph showing complicated relationships, right? So getting into it, as this lake is known to be eutrophic and it's known to have cyanobacterial blooms, we wanted to assess the spatial temporal diversity of the cyanobacterial diversity within the lake. And so we did this via molecular methods, which we'll talk about in a second. And no previous studies, at least that we're aware of, are used molecular methods to characterize the cyanobacterial diversity within this lake. So this is kind of a pioneering study, at least I like to think of it as that. And we also want to identify potential bloom drivers for the cyanobacteria bloom-forming taxa, as well as assess the cyanotoxins within the lake. And so to do this, we sampled 6 sites across 10 outings over the course of 1 year. We sampled up here in the north, which is, again, where the majority of the water is going to enter the lake. And then as well as on the west side, where water exits the lake down the Caloosahatchee River into the Gulf of Mexico. On the east side, where water exits down the St. Lucie Canal into the Atlantic Ocean. And then on the south side, which is going to be more towards the, there's urban areas here, but the Everglades agricultural area where water can move a little bit back and forth. As well as a site in the mid-lake. I know it's not quite the middle of the lake, but it is a large lake and it feels like it takes forever to get out there. So we sampled for microelements such as sodium, potassium, etc. Nitrogen, phosphorus as inorganic forms. We did not assess organic forms of either of those in this study. Basic water quality parameters, chlorophyll, phycocyanin, dissolved oxygen, temperature. Cyanotoxins were quantified using LC-MS, and we used eDNA for barcoding of the cyanobacterial community. And we did 2 primers in this study. We did the cyanobacterial primers, which were described by Newbell et al. And so these are thought to amplify cyanobacterial lineages. But what we saw when we were going through these data is that actually do really well at amplifying the chloroplasts of eukaryotic algae as well as plants. So we lost a lot of our data to the eukaryotic lineages, and we were left with a low amount of reads for the cyanobacteria. But we did do the general bacterial primers as described by Parada, which is going to be 515926, and we were able to get quite a bit of reads, which corresponded to cyanobacteria. And additional data was collected from DB Hydro, which is going to be the South Florida Water Management District's database of hydrological data, which they are frequently collecting from on the lake as well as other water bodies near. And so just a quick slide on my high throughput sequencing and in bioinformatic methods. These were sequenced using Illumina NovaSeq 2x250. We used ASVs instead of OTUs. We assigned taxonomy using CyanoSeq and not Silva. I'll talk about this in the next slide. Removed non-cyanobacterial reads, filtered out low abundance reads except for alpha diversity, transformed when necessary. We assessed alpha diversity using face phylogenetic diversity index, and beta diversity was done using generalized unifrac distances, which leverages phylogenetic relationships. And we visualize these using NMDS. So I just want to touch on CyanoSeq. I know the databases have already been brought up, and this is something that we've curated within our lab, and the manuscript is currently in revision. And that's because we created this because as we're going through these data, we're seeing that a lot of the taxa that are cyanobacterial taxa that are described aren't in Silva, or Silva is missing validly described things, or Silva taxonomy is incongruent with modern taxonomy for cyanobacteria. And this poses a problem because then microbial ecologists who are focused on cyanobacteria, when they're conducting these diversity analysis, they're inaccurately or potentially undercharacterizing the cyanobacterial diversity in the systems that they're working on. So CyanoSeq was created to resolve these issues in the sense of cyanobacterial taxonomy. But why should you care about taxonomic assignment? This can help understand the ecology and diversity of your system that you're working with. It can help properly identify potentially toxigenic genera, such as Dolichospermum, Aphanizomenon, Microcystis, whichever one you're working with. And the ecology and habitat of many of these taxa are well described. One problem that we notice is when we're working with the blooms that are occurring in the marine system, what we frequently saw was that we were getting our reads assigned to Planktothrix, which is a planktonic bloom former in freshwater systems, not a benthic bloom former in marine systems. So there are quite a few issues there, but we know that didn't make sense, and we used CyanoSeq, and it made our diversity assessments much easier. And this is important because eDNA is being used for management, as mentioned in the previous talk, and then names are important. These are the fundamental units of biology, right? So just to go over some of the results, I can't go over everything because I talk a lot, but also some of my results are just kind of boring, unfortunately. We identified several bloom forming genera. Of course, this is eutrophic lake, which is known to form blooms. There's several bloom formers here. But interestingly, we identified potentially novel taxa within the lake, which is very interesting from a diversity standpoint. And the community is at the mouth of the Kissimmee River, which again is where 70 to 80% of the water flows into Lake Okeechobee. Were distinct from the rest of the communities in the lake. So there definitely seems to be a distinct community in the northern part. There was a lot of picocyanobacteria, which are going to be smaller than 2 microns found within the lake, and they seem to be driven by organic nitrogen, but I'll bring up the picocyanobacteria later. Toxins, unfortunately, we only had 8 sites out of our 60 that were positive for toxins, and we found several different congeners of microcystins, nodularans, as well as anatoxin A, and they were all pretty low, around 1 ppb. And this is interesting because nodularans have not been previously recorded from Lake Okeechobee. They're pretty rare to find in freshwaters, and we think that maybe these 2 taxa are the potential producers, but I'll discuss that a little more at the end. So this is a big graph to show the taxa that we found in our sites. So these are going to be our 6 sites that are within the lake, and this is going to be our sampling outings. But what I want to point out is that these were frequently dominated by picocyanobacteria. Again, those really small microscopic taxa. And so that's going to be these light blue, dark blue, pink, and orange bars. And what we can see is they frequently make up more than 50% of the community. And this is really interesting because when you're doing morphological analyses or morphological assessments, you may be missing the picocyanobacteria when you're doing this, when you're doing those morphological assessments. There's also light green here. You're going to see there's lots of Delicospermum that occurred throughout the system, and there were times where it was higher abundance than usual. Microcystis was, of course, found, and at the mouth of the Kissimmee, we see there's a high background concentration of microcystis. And then several other bloom formers, Raphidiopsis, Cuspidothrix, Chrysosperm, Cerasomopsis, etc. Here in Florida, we have 2 seasons. We have wet and dry season, hot and not as hot. And what we see here is that those communities in the wet season are significantly different from those communities in the dry season. And in the wet season, we see a lot more Delicospermum, which we can see here in this light green. We see it's almost double the relative abundance of during the dry season. And in the dry season, we see an increased relative abundance of Raphidiopsis, which is going to be this orange bar here. But the picocyanobacteria are going to be roughly the same relative abundance. Alpha diversity does not differ between the 2 seasons. And as I mentioned before, there's a lot of phosphorus in the system, so there frequently experiences nitrogen limitation. There was no significant difference between nitrogen limited communities and co-limited or non-limited communities. But what we do see, but unfortunately not supported by the statistical analyses, is that when we have these nitrogen limited communities, it does appear that there is a higher relative abundance of Delicospermum, which makes sense as this is a nitrogen fixing taxa. And when we have this co-limitation, it does appear that there's more microcystis, but again, non-significant p-values. And then for drivers, I'm just going to focus today on microcystis and Delicospermum. Microcystis seems to be positively associated with increased dissolved inorganic nitrogen to dissolved inorganic phosphorus ratios, which we can see here. This is a redundancy analysis. So as there's an increase in the DI/DIP ratio, there's an increase in the microcystis relative abundance. And conversely, for Delicospermum, as there's an increase in these inorganic forms of phosphorus, we do see an increase in Delicospermum. And again, this is it's capable of fixing its own atmospheric nitrogen. It does not need nitrogen in the water column. We further corroborated these results from the RDA with a generalized linear mix model. These images unfortunately got compressed, and so they don't look very good here. But these did support the RDA, showing that this increase in dissolved inorganic nitrogen, dissolved inorganic phosphorus ratio leads to an increase in microcystis, whereas an increase in the inorganic phosphorus leads to Delicospermum. We looked at several other variables as well, and it looks like as there's an increase in this inorganic phosphorus, it does lead to a decrease in microcystis relative abundance. And interestingly enough, in addition to the inorganic phosphorus for Delicospermum, it looks like an increase in pH may lead to an increase in Delicospermum, but pH is a little tricky when we're trying to do these analyses. And as I mentioned before, these bloom communities or cyanobacteria form these complex relationships. And I'm not going to get too far into this because this is a mess, as you can tell. But I want to point out that Delicospermum right here forms its own little cluster in this network analysis, where it seems to be correlated to these distinct bacterial classes and this distinct cyanobacterium, unknown cyanobacterium here. Whereas microcystis seems to be correlated to other cyanobacteria, which we know can co-occur with it, such as Pseudanobina, Anathese, as well as a few other bacteria as well. And this is really interesting because there may be some functional roles in these bacterial taxa that help Delicospermum proliferate or thrive, or maybe relationships we don't know about. But there seems to be something distinct with the bacteria that are related to Delicospermum as compared to quite literally everything else. So just to kind of wrap up there, there's a high relative abundance of picocyanobacteria, something that we wouldn't see if we're doing a morphological assessment under the microscope. Delicospermum and microcystis are 2 bloom-forming taxa in this system. They have distinct drivers. They have distinct bacteria associated with them. And interestingly enough, really interesting to me, I should say, is in these nodularians that are being recorded in Lake Okeechobee. We think that they may be produced by Inangainima, we have a strain that we isolated from Lake Okeechobee, and it is confirmed to be a nodularian producer. We've confirmed this via LC-MS/MS, as well as genomic analysis, as well as potentially Dolichospermum. We have isolated a few strains from other lakes in Florida, which seem to be producing nodularian via genomic analysis, and we do have one strain that we have confirmed to be a nodularian producer via LC-MS/MS analysis. So pretty interesting. So I just want to thank you for your attention. I think I may have gone slightly over time. I want to thank my lab members, U.S. Army Corps of Engineers for their support, South Florida Water Management District for their support. These are my lab members. This is my advisor, Big Boss Man. And then this is the QR code for CyanoSeq if you guys are interested. And with that, I will take questions.
Yeah, thank you so much, Forrest. That was amazing. If I think we have time for maybe one quick question, and then we can switch over to our next speaker. Any questions for Forrest? Okay. Awesome. Let's see, Forrest, do you have any further plans? I think that network analysis is super interesting. Do you have further plans for that work, or what are your thoughts on that?
Yeah, continuing to see if there are any bacterial taxa that seem to be specific for cyanobacterial taxa, and we also have some protist data. So that's going to be the eukaryotic algae. See if any of them seem to be correlated with cyanobacterial taxa as well. Trying to assess these relationships using molecular methods, just to see if there's anything novel, anything that has potentially been missed in the literature.
Awesome. Great. Well, thank you so much, Forrest. If you want to put your contact information in the chat so people can reach out to you afterwards, that would be great. And we'll go ahead for the time, move on to our next speaker. We have Paul McKeegan. He's a PhD candidate at McGill University. So Paul, you should have the ability to share your screen. Awesome.
Okay, is it up?
Yep.
You can see it?
Yes, perfect. Looks great. And we can see you in presenter mode. So I'll go ahead and let you take it away here.
Okay, great. All right, yeah. Well, thanks everyone. Thanks for having me. I am currently just finishing up my PhD at McGill University in Montreal. And so today I'm going to talk about just one of the projects that we've been working on that combines both DNA metabarcoding methods as well as traditional microscopy methods for identifying cyanobacteria communities. And before getting into some of those results, I'm just going to talk a little bit about some of the context and the lakes that we are working on. Some of the lakes that are a part of this network that we're working on within Canada that is incorporating molecular methods into our lake monitoring sampling approaches. So really broad context, there are a lot of lakes in Canada. The country alone represents 37% of global lake surface area. There's a high density of them. They incorporate a huge part of the entire landscape. And this is just a map here depicting that high concentration across the entire country. And then amongst all of those different lake dense regions, there's a lot of environmental heterogeneity, both within the watersheds of a lot of these lakes, but also the lakes themselves. So a huge gradient of different lake sizes, shapes, morphometries, nutrient gradients. And that also plays into the diversity of HABs that we see across the country as well. So a lot of different phytoplankton communities, a lot of different cyanobacteria communities, different bloom formers occur across the entire landscape. And this is just to represent visually some of the diversity that we see. So despite this, Canada being a very lake dense region, there's never been a standardized assessment of all of these lakes. particularly one that's targeted towards the health of some of these lakes. And so most of the projects that I've been working on within my PhD have been a part of the Canadian Lake Pulse Network, which was designed to be the first standardized assessment of lake health across Canada using a large-scale sampling approach. So going into the data set that we had generated, it focuses on 664 lakes distributed across the country, which you can see here. They span 12 different ecozones across the country, and they also span a quite sizable eutrophication gradient from ultra-oligotrophic lakes up to hypereutrophic. The lakes were selected using a stratified block design that incorporates for different levels of lake size, as well as the level of human impact within the watershed. So within each of these ecozones, an equal number of lakes would be selected for each of these blocks here. So accounting for 3 different sizes of watershed land use from low to high, and then 3 different size categories. So from each of these lakes, we sampled a wide variety of different environmental metrics, all of which were collected in a standardized way using the same protocol. These include physical variables like just depth, status of macrophytes, level of stratification, presence of birds, and things like that. Chemical variables, pH, nutrients, ions, gases, and cyanotoxins were incorporated into this as well. Different biological variables accounting for different pigments, DNA and RNA from each of these samples, phytoplankton as well as zooplankton samples, and then lastly, optical measurements, so things like water radiance and total suspended matter within the water columns. So all in all, across all of these lakes, we collected approximately 100 different variables. And again, just to reiterate the point that all of which were collected in a standardized fashion. The sampling strategy itself was monitored quite closely to the National Lakes Assessment that you have across the US, whereby all of these lakes were sampled just once as a sort of snapshot approach during the sort of peak summer months and growing season. Within the network, there were 4 different themes in order to investigate the health of Canadian lakes. The first looking at or trying to understand where, by how much, and why Canadian lakes have changed during the Anthropocene. So this has incorporated a lot of paleolimnological studies. Theme 2, looking at how taxonomical, molecular, biochemical features of both planktonic and microbial communities have changed in relation to different human impacts within a lot of these watersheds. A third theme, looking at different optical and morphometric properties of lakes, so that we can sort of scale up individual lake assessments to be able to apply them to a much greater area. And then the fourth theme, looking at how ecosystem services respond to or have been affected by different levels of human impact within watersheds. And for some of the data that I'll just show today quickly all have to do with this theme 2, where within this theme, we're looking at different phytoplankton communities, zooplankton communities, both using traditional approaches, and then also incorporating a lot of molecular approaches to analyze these communities as well. So within this network, of course, a key metric of water quality is the analysis of cyanobacteria and HABs. And so with that was, of course, a big part of the network. And there were several different projects related to improving our understanding of cyanobacteria dynamics across Canadian lakes. These are just a couple of projects. One looking at a much more detailed analysis into the drivers of cyanobacteria in the community. So that's incorporating a much broader or expanded range of potential predictor variables, again, that were collected in this standardized fashion. 2 is we did do a distribution or an analysis into the distribution of cyanotoxins across this landscape as well. So using the same set of lakes, we quantified total microcystin, as well as performed a detailed analysis into a series of microcystin congeners. And then we also did 15 additional peptides and alkaloids, again, collected from from all of these lakes. So all of those data are currently being included into different projects and should be made publicly available somewhat soon. And then lastly, just some of the data that I will show today was a part of a project looking at taxonomic comparisons between molecular and microscopy generated communities, specifically for the cyanobacteria component of the phytoplankton assemblages. So the idea for this project was sparked by a couple of different sources. One just being that there were a lot of people within the network who were doing projects on bacteria as well as phytoplankton, sort of separately. And they were using both the microscopy generated data set that we had done for all of these sites, and then others were using 16S metabarcoding data that were generated for all these lakes as well. And we were sort of doing these projects in different camps. And so there was kind of a thought, well, we're working with these communities that we assume are the same, but we're using different methods. So is there a way that we can maybe check to see if they are at all congruent with one another? And it's pretty low-hanging fruit. And with the emergence of DNA metabarcoding techniques, these sort of comparative studies have become a lot more common across a lot of different aquatic communities. This was a meta-analysis published this year by Francois Keck, who used about 215 available sort of comparative data sets across a wide variety of aquatic organisms and just assessed their congruency between the two methods. Overall, the methods were much more highly congruent for larger organisms like fish, but when we went further down to smaller organisms, like plankton and microphytobenthos, they showed a lot more pronounced differences. And so with the large data set that we had, we thought we would take advantage of that and do the same sort of comparison across Canadian lakes. So specifically for this project, we took a subset of lakes from the network. We took 379 lakes from across the country, shown here. And this map is just showing log transformed cyanobacteria abundance from all these sites. So in the more red color is where we see our higher abundance in biomass, and sort of lighter you can see during other, the lighter color in yellow is lower concentrations. And so across the country within this data set, we see sort of a spike in central Canada here within the prairies. And these regions here, they're used for a lot of agriculture, and they're also naturally quite eutrophic lakes and have been for centuries. But the data set that we generated here from each of these lakes, we took an integrated whole water sample, so just an integrated of the top 2 meters. And then we generated the microscopy phytoplankton community using samples that were preserved in lugalls, later in the lab settled using utermal sedimentation method, and then eventually counted on an inverted microscope. And all of that was done by a single taxonomist. And then from each of these lakes as well, we had generated the molecular data set. So water were filtered on site during the day of sampling. They were later shipped to a lab that was tasked with doing the laboratory component of this. So sort of downstream analyses, did sequencing of the 16S RNA gene, focusing on V4 region using Illumina MiSeq. And for this particular project, because so many people were using the molecular data set and looking at different bacterial communities, we had just stuck with universal bacterial primers for now. So in the end, what we had generated were 2 different data sets for each of these lakes. So in the middle ring here, for each lake, the cyanobacteria assemblage generated by the traditional microscopic method. And then on this outer ring, for each of those same lakes, the community generated by DNA metabarcoding. And we had 2 sort of broad objectives to try to address with this data set that we had generated. One was just to quantify the congruency between the two methods, or the communities between the two methods. And then later on, look at regional variation of different genotypes within some taxa, particular microcystis. So there are a lot of different ways that you could compare the two data sets, and one that's often done in these sort of comparative studies is rather simple, is just checking to see what methods are identifying which community or which taxa. So that's just what is showing here. So presence absence for each community or each method. And then in the circle, in the middle circle, looking at taxa that were generated by both methods or found at least once by both methods. So a lot of our sort of common bloom formers are incorporated into here, like Phantasomum, Dolichospermum, Microcystis, Planktothrix, among many others. But there, on top of that, though, there were taxa that were generated exclusively to each individual method. So that's sort of a simple way of looking at taxa from these methods. But we wanted to do it quantified a little differently. But before doing so, one thing we did do was that we know that sort of before that the identification of cyanobacteria, especially based on light microscopy, is difficult for many taxa, and just there are a lot of taxa that are indistinguishable. So what our taxonomists did had sort of created these complexes with several genera within them in order to limit this bias that is sort of obvious before even getting into comparing the methods. So just looking at the top 10 genera and genus complexes that were generated by each method. So in the first two here were just biomass as well as cell abundance for the microscopy method. You can see here that most of our, again, these common bloom formers are representing the majority of biomass as well as density. So our Phantasomums, Dolichospermums, Microcystis. The order varies a little bit, but the trends are still the same in terms of what is coming up as the most abundant. But then when we compare that to the percentage of sequences assigned to cyanobacteria, it's overwhelmingly dominated by our picocyanobacteria complex here, which we're calling Synechococcus, representing the overwhelming majority of sequences. And then some representing a smaller share of these common bloom formers are sort of distributed differently as we move further down the list. When we look at just average relative abundance of these groups, overall, they're quite low. But the group that is dominating across all of these lakes within both methods is sort of this Synechococcus complex, or picos. Here with the metabarcoding method, they overwhelmingly represent the majority of most of the sequences. It's still high with microscopy, but it's certainly lesser. And then there's varying levels of relative abundance of sequences distributed across these different groups. And then when we look at just the simple frequency of occurrence, so the number of lakes that these taxa are occurring in within the metabarcoding site, these complexes typically are found across all of our sites, so all 379, whereas in the microscopy set, their occurrence is a lot more sporadic, regional. They don't necessarily occur everywhere. But within this, though, the group that is found in the most number of lakes, of course, is the our Synechococcus and our pico group. So another way of assessing the similarity between these two methods was through simply ordinating the communities. And what we saw through this method was that the methods are a lot more similar along a trophic gradient. So when we ordinate all of our sites and do a PCA here on the left from the microscopy data set, we see several of our complexes here sort of being separated from one another, but they're organized according to trophic states. So here in green are most eutrophic sites. We see Microcystis, Planktothrix, Phantasomum, Dolichospermum, and sort of opposite to that is our pico group here, Synechococcus, and with that being a lot more characteristic of our mesotrophic and our oligotrophic sites. And that's also replicated within the DNA metabarcoding site here on the right, where the site distribution is slightly different, but the taxa ordinate along the same pattern. So our common bloom formers being a lot more characteristic of our higher nutrient sites, and our opposite to that are our pico groups and our lower nutrient sites. And we can visualize that relationship here with just using simple bar graphs. So this is looking at the average relative abundance of these taxa and these complexes with between each method, and they're organized on the x-axis according to the nutrient status of the lake. So with the DNA metabarcoding method in our oligotrophic and our mesotrophic sites, the percentage of sequences that are being assigned to our picocyanobacteria complex are, of course, the majority of the sequences here. So consistently over 75% of the entire cyanobacteria community being generated with this method. As we move up higher to our eutrophic and hypereutrophic sites, that distribution here in red sort of decreases, and we see the emergence of more common bloom formers. So our Aphantozomenon here in brown, Planktothrix here in purple, and then our Microcystis in this lime green. And when we look at those same relationships within the microscopy generated community, of course, the same groups are dominating, but the relationships are the proportion of the data set are different. So of course, in our lower nutrient sites, the pico complex within microscopy is still the majority, but it's certainly not as dominant as it is in the metabarcoded community. And then we go, as we increase our nutrient state, we see more Aphantozomenon, again, Planktothrix and Microcystis, to where our picos and our hypereutrophic sites are really representing a very small portion of the cyanobacteria community with this method. So that's just looking at the communities that were generated. We were looking for different ways to sort of quantify the similarity between the communities. So this was one way that we had done so using RV coefficients. And they're sort of analogous to a Pearson correlation, but for not sort of single variables, but entire matrices. So what we had done was in all of the different versions of the communities that we had compared, we had first ordinated them using PCA. We had extracted the site scores of all the lakes within those PCAs. And then using those site scores, calculated this RV coefficient that to assess the similarity. And this is on a scale of 0 to 1, 0 meaning they're entirely different, 1 meaning they're a perfect match. So we had done comparisons across different iterations, I guess, of the data sets. But the one thing to note was that whenever we are comparing sites that were just the eutrophic and the hypertrophic sites, the communities tended to agree a lot more, or at least a little bit more in most cases. So at the first comparison here would be at the order level of taxonomy. So our broader levels of taxonomic assignment. And here with all of the sites in this gray bar, the communities agree close to around 27%. And then at the order level with all of with just the eutrophic and the hypereutrophic sites, that level of agreement increases to about 40%. So that's at the order level. And then if we go down across these different subgroups, we had compared different levels. So looking at the family level taxonomic assignment, and then at the genus level. And then we had different versions whereby we had done genus level with the picos removed, because as Forrest pointed out, it's a huge bias with the microscopy generated communities, whereby we often miss that component of the phytoplankton assemblage, especially with the Utermole sedimentation method. But the level of congruency tended to decrease as we go down to finer levels of taxonomic assignment. And then when we did, and then they were lowest when we actually removed the picos from the data sets. And then when we went, these levels of congruency started to increase again as we had made further modifications to the groups that we're comparing. So when we did genus level comparisons, but we established a minimum number of sequences, when we are only comparing lakes that had a certain number of sequences assigned to cyanobacteria, that level of congruency starts to go up again. And then a little bit more towards the very end, whereby we're doing genus level comparisons, removing the picos, and also establishing a minimum number of sequences for the metabarcoding data set. But overall, the highest level of congruency that we're getting between these two methods, at least according to this particular method, is about 40%. And I should say too, this was replicated with a cyanobacteria biomass as opposed to cell density, and the level of congruency was basically the same. So there were, in order to sort of explain why these levels of congruency might appear to be somewhat low, were just a lot of technical as well as biological considerations. So of course, on the technical side, just the amount of water that we're comparing here, they're quite different. With microscopy, we're typically using between 2 and 10 milliliters versus metabarcoding within the field where we're filtering up to 500, but it was usually at least a couple of hundred milliliters. The underlying units of the two methods, of course, are really different, comparing individual cells versus ASV sequences. Primer selection here assumed to be quite relevant, although we didn't get an opportunity to explore different primers because they were just sequenced with these universal primers. But certainly that would definitely have an effect on the results. And the detection limit of the two methods. So with the utermole method and inverted microscopy, capable of cell below a certain size, and mainly around micron or so. And that restricts our identification of picocyanobacteria. And that's kind of shown here, whereby in the metabarcoding data set, the percentage of sequences assigned to picos is extremely high in most lakes, consistently above 75%, versus the microscopy, where these picos represent a much smaller portion of the entire data set. And then some biological considerations here as well that may have impacted these levels of congruency. There are just gene copy numbers within the 16S RNA gene. This differs quite a bit between members of the Nostacales order versus Seneca. And then, as of course all of you are aware, and this has been brought up a couple of times already, is just the state of reference databases, whereby several of these taxa that were identified were with microscopy. We just did not have representative sequences in the databases that we assembled to use here. And then lastly, I'll just have one slide on this really quick, but I guess one advantage of using the DNA metabarcoding data set was looking at sort of really fine level variation within communities to see how they vary across space and vary according to different environmental conditions, which can be difficult with microscopy, especially it's certainly possible with species level, confident species level identification, but we ASVs within certain communities of interest, like microcystis, in order to see variation within these genera across all of our sites. And this is just a PCA showing ASVs within microcystis being characteristic of lakes of different nutrient status, whereby here a couple of lakes or a couple of ASVs were much more characteristic of our high nutrient lakes, whereas others were much more characteristic of our lower nutrient sites. So that's something that is able to take advantage of with this data set. I guess overall with this comparison, a couple of key findings were that the level of congruence between these two methods were much higher at coarser taxonomic levels, so at our order and our family level. And they also agreed a lot higher in our lakes of higher nutrient state. Certainly, I guess from a management perspective, when deciding which method to use, definitely does show at least metabarcoding could become more widely applied to study blooms, which are of course characteristic in more eutrophic sites. As we showed, the level of congruency may not be great, but it's certainly higher in these lakes of high nutrient status. And that overall, and this has been pointed out by several of these sort of comparative studies, not just with cyanobacteria, but with other communities as well, is that the methods give complementary rather than identical community information, whereby with the microscopy, we're really missing a lot of the picos, but the DNA metabarcoding approach is able to sort of account for that part of the phytoplankton assemblage. And of course, all of this will be improved with increased representation in reference databases. I think, am I out of time here? Must be close.
You're getting close, yeah.
Okay. Yeah, and I guess just to conclude, additional considerations into selecting your approach as well, of course, is cost and time and level expertise, which we dealt with a little bit here as well. And then lastly, if it's of any of interest at all, within our network and the Lake Pulse network, there's been a much more attention in order given towards integrating molecular methods into our sampling programs. So within the network, they did actually a quite good job of this, whereby across all of these sites, several have looked at community or bacterial communities using 16S, eukaryotic communities for 16S sequencing that was done on all of these. We've assembled about 300 individual metagenomes for all these lakes as well, which people are currently working on, all of which will eventually be made publicly available. And these techniques have been used to study all sorts of different anthropogenic stressors, levels of diversity, in particular, as well as antimicrobial resistance genes, so among many others. But thank you very much. And here's my email if you have any questions. Feel free to reach out. And yeah, happy to take any questions if there's time.
Awesome. Thank you, Paul. I think we unfortunately don't have a ton of time for questions, but thank you. If you want to put your information also in the chat so people can have it, please feel free to reach out to Paul with questions. So that was super fascinating to see the comparison of the methods. So I think our next speaker is Isha. Isha, you should have screen sharing abilities if you want to try that.
Yeah.
Great, looks good. Yeah, go for it.
I really enjoyed both the talks. I think they were like pretty great. And I already see lots of similarities between our analysis and their analysis. So yeah, a good set of talks. But hi, everyone. I'm Nisha Kalra. I'm a postdoctoral scholar in Karen Lab at USC. And today I'll talk about diversity and dynamics of cyanobacterial and eukaryotic community in Clear Lake. So a lot of people aware of this habitat. So Clear Lake is situated in the north central region of California. It's one of the largest lake within the state. It's highly eutrophic, highly productive, and has a distinct morphology. It has three main arms. So you have the upper arm, which is the largest arm and also the shallowest arm of the lake. Then we have the Oaks arm, which is on the southeastern region of the lake, as well as the lower arm, which is on the southern side of the lake. Clear Lake has had many historical water quality issues, including mercury contamination, pesticide runoff, but more recently we've had increases in cyanobacterial harmful algal bloom and increase in concentration of cyanotoxins. And mainly it's been observed that in February, the cyanobacterial blooms start forming in the upper arm of the lake, and then due to the northeasterly winds, they then get deposited into the Oaks arm and the lower arm, where they really intensify and start producing toxin at a very high level. So cyanotoxin have been measured in Clear Lake ever since 2015, and we have a good analysis of especially microcystin in the lake. So many cyanotoxins have been seen in the lake, including microcystin, anotoxin, nodularin, but we have one of the best databases for microcystin. So here is a graph from recent Jamie's paper showing the microcystin levels in Clear Lake ever since 2012. So as you can see, these lines depict the CA trigger levels of caution, warning, and danger level, and we frequently see microcystin levels above the warning and danger levels. And also the levels are highest in the lower arm and the Oaks arm, which are depicted in blue and orange over here. But we also see a lot of variability all throughout the years in the microcystin levels. Sometimes they're really, really high. So one of the questions that arises is what is really impacting these variations, year-to-year variation in microcystin, and how does the microbial community actually contribute to those changes? Next here, we're seeing the monthly patterns of the microcystin occurrence at Clear Lake. So you again have the microcystin levels in the y-axis and the different months of the year on the x-axis. And here you can see how microcystin is detected almost every month, but the levels really start increasing during summer in June. And one of the highest microcystin concentrations are observed in August and September. And again, you see those high variability in different years. So we really want to understand how this succession of changes in microcystin concentration happens, and how is the microbial community succession really contributing to these changes in microcystin. So our overall project goal is to investigate the plankton community and cyanobacterial species response to environmental drivers of cyanohab in Clear Lake. And to do that, we're using DNA sequence information to really understand both the cyanobacterial as well as the eukaryotic community dynamics and succession in Clear Lake. This is the first molecular survey of Clear Lake, which will provide new perspective on both the cyano as well as eucs in the Clear Lake and how they really contribute to the cyanohab dynamics. And overall, our main goal is to really investigate the relationship between these microbial communities and understand how they might be contributing to these dynamics. And for that, we are in process of doing network analysis to understand heterotrophic bacteria, cyanobacteria interaction, as we saw how important they are in the previous talks, and also uncover the relationship between the eukaryotic and cyanobacterial species, and specifically look at predator-prey interaction or mutualistic interactions that might be happening in the lake and contributing to the toxin production. So for this talk, I'll mainly be focusing on two questions. The first question is, what are the yearly patterns of these microbial community dynamics in Clear Lake, specifically looking at the month of August, when we see one of the highest concentration of microcystin. And we have 3 years that we sampled, 2019, 2020, and 2021. And we did both 16S, 18S rDNA sequence analysis using the universal primers. And we did 5 sites for these analyses, 1 in Oaks arm, 1 in lower arm, and 3 in upper arm. Our next question was to understand what are the monthly succession patterns of these microbial community, specifically looking at these high bloom months of July to October. And we sampled during 2021 in these 4 months, again, looking at both the 16S as well as 18S rDNA sequence analysis in these 5 sites. So first, looking at the yearly changes in the chlorophyll and microcystin levels at Clear Lake in August during the 3 years that we sampled for DNA. We saw that overall chlorophyll levels were highest in 2021 at Oaks arm compared to the other side, whereas the microcystin levels that are shown here were highest in the lower arm, which is the S9 site over here, and does not correlate with the chlorophyll levels in the lake. When looking at month-to-month changes, we saw that the Oaks arm, which are here in red, and the lower arm, which are here in green, had the highest level of chlorophyll, especially in the months of August and September. And then we saw huge increases in microcystin levels in September, specifically in the lower arm, where we had consistently higher levels of microcystin. So looking at total contribution of cyanobacteria to the bacterial community, here are all the samples that we did the sequence analysis for from 2019 to 2021. And this is the relative abundance of just the phyla level of the 16S sequence analysis. And we saw that the cyanobacterial community, which is depicted here in purple, contributed about 20 to 55% of the total bacterial community. So it's pretty, cyanobacteria is pretty dominant in the bacterial community. So one of our first results looking at the major taxa that dominate the cyanobacterial community during August. Here are the 5 sites that we looked at. So we have the site S1, which is in the Oaks Arm, site 4, 5, and 7 in the upper arm, and site 9 in the lower arm. So looking at the relative abundance of just the cyanobacterial taxa in these sites, we see that the community changes year to year. In August, we see Dolichospermum dominating in the Oaks arm, whereas Microcystis dominating in the lower arm in 2019. And then we have the Synobium, which is the Picocyanobacteria we've seen before, which is really dominating the upper arm in the lake, along with the presence of Aphanizomenon, which was only present in 2019 August, but we didn't see it in 2020 and 2021. Interestingly, in 2020, the community was dominated by Dolicho as well as Formidium, especially in the Oaks arm as well as the lower arm sites, along with the presence of the Synobium Picocyanobacteria. Then in 2021, we again see Dolicho forming a dominant member of the community, along with Microcystis being present in the Oaks arm as well as the lower arm site, along with Limnothrix and Synobium. Looking at how the cyanobacterial community changes during summer and fall months in Clear Lake, we see a succession of the cyanobacterial community during these months. We have Formidium forming a huge part of the community during July, really being dominant, especially in the Oaks arm and the lower arm of Clear Lake, and also in the upper arm sites. But we have again Synobium, which is the Cyanobacteria being present. In August, the community then shifts to Dolichospermum, which we've seen before was really present in 2019 as well as 2020 August samples as well. And we have the Microcystis being dominant in the Oaks arm and the lower arm at Clear Lake. In September and October, the community then shifts to Nodularia being really dominant overall in Clear Lake, but lower arm is still dominated by Microcystis. And it then again changes to Planktothrix kind of taking over the community in October. So you really start seeing the succession of these different cyanobacterial genera, and all toxin producing, that become dominant in these lakes and might be contributing to the different levels of microcystin that we see in these sites. Jumping to the eukaryotic community, in August and all these 3 years, we see changes in the euc community year to year. But one of the most dominant taxa is chlorophytes in the lake, which were pretty dominant in 2019 at all the sites. But we had metazoa kind of overtaking in lower arm site, which is interesting because this metazoa was mostly comprised of rotiferas, which have been shown to kind of feed on Microcystis bloom, which was in the lower arm site at the same time. Then in 2020, we have increase in oprophytes and cryptophytes, kind of changing the community composition towards more of these taxa. In 2021, you again have chlorophytes, cryptophytes, but increase in metazoa at the sites where we have more Microcystis present. Looking at the succession of these euc communities during the different months, we see again different patterns of composition in euc taxonomy. Especially in July and August, you have chlorophytes that are really dominating the community. But then in the arms that are dominated by Microcystis, you have increase in metazoa. And in September and October, the community then shifts towards more of ochrophytes, cryptophytes, and Celiophora that dominate the community, and the chlorophytes start decreasing. So also we wanted to understand what are the patterns of the community structure in August during all 3 years. So we did the principal coordinate analysis, which we have seen some of these same analysis in the last 2 talks. These are just the average of the samples that we've used. So we have the different years here, 2019 in brown, 2020 in green, and 2021 in blue. And the 3 different sites, Oaks Arm in circles, upper arm in triangle, and lower arm in squares. And we kind of see that this community is kind of weakly clustered together with different years, showing that the Sino community does not really change that much year to year. But we do see the Oaks Arm and the lower arm sites kind of aggregating away from the upper arm sites because they're so different from the 3 sites that we had in upper arm. Looking at the Ute community, you start seeing more differences year to year in the Ute community, where all the different years kind of aggregate together away from each other. Then again, exception being the Oaks Arm and the lower arm side that kind of aggregate away from the same year. Looking at the monthly patterns of the cyanobacterial and eukaryotic community, we again have the PCA plot with different months depicted here in different colors. You have July in brown, August in green, September in blue, and October in purple. You can see there's sort of aggregation happening with the different months, telling us how different the community is at these different months. But we again have the Oaks Arm and the lower arm kind of separating from the upper arm community, showing how heterogeneous the Clear Lake cyanobacterial community is. Looking at Ukes, you again start seeing that pattern of different months aggregating together, telling us that there's a succession in community, in the eukaryotic community as well, where different months sort of cluster with each other. Next, we wanted to understand the correlation of different environmental factors to the cyanobacterial community succession during 2021. So just looking at the different months and how the environmental factors that were measured really correlate with the community. So we did this analysis where you see the different environmental factors that we measured. You have the phosphorus, nitrogen, chlorophyll, and the microcystin, and how they really lead to the changes in the community. So here we can see that the total phosphorus is negatively correlated with the July community, but positively correlated with the September and October community. Whereas the nitrogen is positively correlated with the October community. And we see all these sites that have higher microcystis levels, which is the Oaks, the lower arm and the Oaks arm kind of positively correlated with microcystin levels, which makes sense. Looking at the eukaryotic community, so even the eukaryotic community was correlated with these environmental factors, with, again, the total phosphorus being negatively correlated with the July community, but positively correlated with the September and the October community. And especially the nitrogen levels were positively correlated with the October community, even in the eukaryotic community. So some of the preliminary conclusions from the study is that the yearly community analysis revealed that the August cyanobacterial community in Clear Lake is dominated by Dolichospermum, Microcystis, and Formidium. And here I kind of want to underline that we were not really expecting Formidium, but Lyngbya to be dominant during that time, because that's what we saw with the microscopy analysis. I've been using Silva for my identification, and I think we might be really limited in selecting for Lyngbya here. So we might be using the database that Forrest talked about and see if we can have a better identification of our cyanobacteria. We saw monthly succession of the cyanobacterial community, which was evident with different potential toxin producing genera kind of dominating in different months. So we saw the Formidium lingua bloom first, then being dominated by Dolichospermum and Microcystis, and then changing into a community which was dominated by Nodularia, Microcystis, and Limnothrix in the fall. We saw that the total phosphorus and nitrogen levels correlated with the changes in community composition and might contribute to the overall cyanohab dynamics. And we also saw, and we think that the increase in nitrogen fixation by certain nitrogen fixing cyanos during summer might contribute to the dynamics in the fall. We saw that the eukaryotic community was dominated by chlorophytes, cryptophytes, and oprophytes. And the community composition varied yearly during August. And we also saw succession of the euc communities from chlorophytes to oprophytes and cryptophytes from summer to fall. And we also saw, again, the community being affected by nitrogen and phosphorus during the monthly changes in 2021. So with that, I would like to thank all of my collaborators, lab members, as well as people who really helped with the sampling, our collaborators at Big Valley, Elam Indian Colony, and Central Valley Regional Water Quality Control Board. Support comes from Dornsife and our USC Dornsife, and our funding comes from California Water Board. Thank you.
Thank you so much, Isha. I think we have a little bit of time for questions. So let's see. So Becky, you put a question in the chat. Do you wanna ask that?
Sure. I know I work with Sarah Ryan on the CalWatch project, and as was just identified, seeing Formidium. And so I'm just curious, I would assume the source population is growing attached somewhere. And this is detecting different fragments, but I don't know if anyone who's done research has actually seen, the attached growing sources of Formidium.
I'm not really sure of that. Dave, if you're still here.
It looked like Dave was here. Let's see. Looks like he might have dropped off. I think maybe Sarah, have you ever seen, Sarah, you obviously, your team works a lot in Clear Lake. Have you ever seen attached mats?
Not that not that we've noted, but we're obviously seeing Formidium on the shoreline. So that's something we'll continue to look for.
Yeah, it's kind of interesting. See other questions for Isha? Awesome. Okay. So Isha, where are you can you speak a little bit about where you are planning to kind of take your analyses from what you showed? What's your kind of next steps that you're planning?
Yeah, so the next step is doing network analysis, really looking at the heterotrophic cyanobacteria interaction as well as eukaryotic cyanobacteria interaction, and kind of identify these keystone species where we see big interaction with the toxin forming cyanobacteria, and see how they are correlated with those taxa and how they might be contributing to the microcystin production in the lake. That's majorly where this project is going. Yeah.
Awesome. Yeah, so kind of taking a different view, kind of looking at biotic and top-down type interactions.
Yes, especially looking at predator-prey and mutualistic relationship that we might find in the lake and are important. Yeah.
Great. So Christine Job is on chat, asked, were there any other toxin analyses that were conducted besides microcystin?
Yeah, I believe anatoxin, we tried to measure them, but we didn't detect any endotoxins. Yeah.
Awesome. Cool. Other questions for Isha? Or everybody's eager for lunch now? Awesome. Well, thank you so much to Isha and Paul and Florist and Susie for your talks. It was great to kind of hear from all these really amazing molecular approaches for assessment of HABs. And so I think right now for the agenda, we'll go ahead, we're going to take a lunch break. And then when we come back, we have some report outs from the CCHAB work groups, as well as some discussion on reconvening the benthic HAB subcommittee. So we'll sign back on. I'm going to leave the Zoom line open, but we'll reconvene at 12:50. So everyone, stretch your legs, get a glass of water, eat some lunch, and we'll see you soon. And we're back with a few more agenda items. So right now we're going to move into our CCHAB work group subcommittee year-end reports. And so we'll go ahead and start with Becky Stanton, who will be giving us a quick update on the illness tracking work group. So Becky, if you want to take it away.
Great, thanks, Jamie. Whoa, too many slides. Okay, just a brief overview for those who are less familiar. It's an interagency work group. We began work in late 2017. It's interagency, meaning it involves staff from Department of Public Health, the Water Board, myself and Shannon Murphy from OWIHA, and California Department of Fish and Wildlife. And so we respond to human and animal illness reports that are potentially related to HABs statewide. We split up the response to individual cases just to help divvy up the work and tie it to our key agency roles. So CDPH and Tracking California usually leads on the human health interviews and follow-up. We pick up with domestic animals, and then CDFW coordinates for fish and wildlife. And then water boards help us tag in with local response, sampling, and provide great support for that. And then we work together as a work group on what are considered HAB-related. We do then track all these cases and complete the documentation for our own tracking, as well as submitting it to California, Center for Disease Control and Prevention's One Health Harmful Algal Bloom System. And then we work on outreach materials, which I'll cover briefly, to different audiences. And we also participate in monthly community practice calls with other states and federal partners. Just in terms of timeline of how this looks like, usually we're looking at acute short-term exposure events that might be minutes or hours. For the neurotoxins, they're known to be generally fast onset, so minutes to hours, whereas hepatotoxins like microcystin or cytotoxins like cylindrospermopsin may have symptoms beginning within hours to days. Usually we look at about a 2-day window for onset, but some symptoms may occur later than others. The actual illness report being received, obviously we don't control. We encourage people to report as timely as possible, but that doesn't always happen. So sometimes we're hearing about these quite a bit after the fact. We work to schedule an interview as soon as possible. And identify if there are any potential specimens that are available and what conditions they are being stored in, so that we can hopefully see what's available, possibly collect a urine sample from a dog and freeze it as an example, basically to hold that potential opportunity while we investigate further. We'll try to get water or cyanobacterial samples as soon as possible. Ideally within a week, but we have looked if conditions are fairly similar further out. In some cases, there's routine monitoring, so they already had samples in best case both before, and soon after an event. And then we have a certain hold time for those samples to keep looking at, and certainly if we have things that we can freeze, that gives us more flexibility. If there is an unfortunate death, we don't have a lot of time until we can figure out what we can do there. And then if we happen to have urine, again, we can hold those frozen for quite a while. So it's just kind of a process, and things are often linked to each other. So it's kind of sequential in terms of if things are lagged further behind. So for data collection, this is based on what the CDC forms look like, but again, it's useful information that we use for our state purposes as well. So that it's split between an environmental form, so that talks about what the water body characteristics are, what the conditions are in terms of HAB monitoring or sampling, anything else that might be relevant for that water body. And if it is foodborne, then there's information about the where and what species may have been harvested. The human and animal forms fairly similar in terms of information about those individuals. For animal forms, you can submit as a group. So sometimes, like for fish kills, we do that. Information about what was happening when the individuals were exposed, and if we know about how long they were doing that activity, when exposure might have occurred. And then the signs and symptoms, any information about history, if we, in the rare cases, have clinical testing, and then what else might be tested for. Sorry, my mouse is touchy today. Then we work through all that information. Sometimes it takes quite a bit of time to get all the different pieces together, but then we discuss as a group and bin into either HAB related or not HAB related. So HAB related means we had enough information on both the illness and the individual. We had sufficient information documenting potential exposure to HABs, and we have information about the cyanobacteria or cyanotoxins that are consistent with what types of symptoms and what severity. Unfortunately, most often we end up in not HAB related for the basic reason of we don't have enough information. So it could be that we've had wildfires that limited access back into that water body area. Sometimes we don't get responses further from the individuals, or we didn't, sometimes something was submitted anonymously. So there's a lot of different reasons it might not be HAB related that have nothing to do with whether or not an event actually occurred. So it really constrained that way. But in some cases, we do have that the signs and symptoms are not consistent in terms of onset or likely related, or there's another more likely cause of illness identified. And in some fortunate cases, there was a likely exposure, but symptoms did not develop. And so it's basically not an illness. So we consider that potential exposure only. So as I mentioned, and is really key, is the timing is really critical. And again, it sort of compounds through the notification response. If we don't hear about it until weeks after the event occurred and it's not otherwise routinely monitored, then any samples were collected are really going to be hard to relate to what's happening at the time of the exposure. We also run in, I think has come up earlier today, about time of year. Sometimes, yes, blooms may like it hot, but there are situations where we get blooms year round or different successional species. Like we're now, as was mentioned, a lot of places are still at warning or danger. It may be a different species that's blooming now than is occurring in August or September, but that doesn't mean we don't have an issue going on. Also, there may be ideas about water body types that constrain whether or not it'll be potentially reported. So we're trying to get outreach about that. And if it's a private or restricted access water body, again, we need to prioritize our efforts in terms of response and follow-up. And so there's some constraints that occur if that's where the exposure happened. We still have pretty limited options for biological sampling. And certainly other toxin classes or specific congeners are limited on the analytical side. And then in general, for chronic exposure or potentially chronic illnesses, we don't have a mechanism to address those at this point, either at a state or federal level. So with all those said, for 2021, which is the last year in which we've completed our summary. We're almost there, starting to work through that for 2022. But we had 82 initial reports of potentially HAB-related illnesses received for freshwater. We did further evaluation, and as mentioned, we had those we determined to be HAB-related, and those who reported in, and that was 34 cases total of the initial 82, and those were 14 humans, 12 dogs, and 8 fish events. And we map out by county, and so we've put maps that are either human only, human or animal only. And then we put this together into both English and Spanish web pages, which are a little more detailed and condensed fact sheets. And certainly appreciate any attempts to help share this information. And as we're also working on updating these with our 2022 illness tracking summaries, as well as other resources that may have come out in the last year. So if you have any suggestions, feel free to email me. For marine HABs for 2021, a bulk of this is unfortunately California sea lions that come ashore with exposure to domoic acid and are symptomatic. They come into or receive notification in through the marine animal rescue centers throughout California, and then are reported into the Southern California Coastal Ocean Observing System, or SCOOS. And then we track those. But we did also have 1 die-off of marine invertebrates and 1 human illness following water contact. And we have a similar look and feel to our marine HAB related illness tracking fact sheet. Again, other resources, a summary of our cases to date, contact information, and that is also in English and Spanish, and we will be working on updating those shortly. So just in general, again, appreciate as timely notification of any potential reports. Again, we're not suggesting you have to triage those you think are most likely. We're happy to hear about all of them and coordinate with those individuals to do follow-up. And at a minimum, it gives the opportunity to do outreach. Again, there's the great weekly updates from the California HABs portal now. Both SCOOS and CDPH do monthly reports out on the marine side. And of course, we always recommend people attend these meetings to learn more. And if there's any public health or animal health related topics or any outreach, feel free to contact us. And with that, that's my information, and happy to follow up with any questions.
Great. Any questions for Becky? If not, oh, go for it, Sarah.
I had a question in the chat, and that was, Becky, would the illness work group be able to give us numbers by county of the confirmed HAB-related illnesses?
Yeah, we should be able to do that. Just to be clear, I know the terminology gets a little tricky, but we would be doing all the ones that we consider to be HAB-related. It wouldn't be CDC's uses confirmed, probable, and suspect, and we don't split to that level. But yeah,
just the HAB confirmed ones.
HAB-related.
HAB-related ones.
Yeah. Sorry.
Is that something that would be that could go onto that map, like just the number of the confirmed ones at the end of the year, or is there a different way to do that?
We've just done it by the kind of the maps we showed, but I think it'd be possible to put the numbers. We just don't want to be too narrow in terms of the geographic specificity for HIPAA concerns for the human cases. So we just follow that as a general practice, but the county level, we've been able to do that.
Yeah, I was just thinking the county level would be helpful.
We've also talked about doing it by looking at it by month because of the trying to highlight, that we do have things coming in throughout the year. Thanks.
Yeah, thank you.
Thank you, Becky. All right, so we also are going to hear from our mitigation subcommittee. So Hugh, if you want to take the reins here and give an update, that'd be awesome to hear from you.
Sure. Thank you, Jamie. Hugh Dalton. Good afternoon, everyone. Today I'm reporting on the year-end work of the mitigation subcommittee in 2022 and also a short preview on our 2023 work assignments. Beginning with 2022 is a quieter than previous HAB years, likely due to record low rainfall recorded in 2022, along with lower summer and fall seasonal air temperatures, in addition to a multi-year drought preceding 2022. The vast majority of CCHAB reports on the state portal were either cautionary or no active blooms detected, and a very small amount of warning and danger level HAB reports. A few of the trouble spots that are kind of yearly offenders included Tahoe Keys, some lakes in the East Bay Parks, Pinto Lake in Watsonville, and Lake Elsinore in Southern California. A highlight for new and different emerging technologies we're seeing. A few presentations were given to our HAB response team of Dave Karen, Bill Taylor, and myself. Two of these bioremediation vendors were WQ3D Treatment and NBioorganics. Both of these vendors apply wastewater treatment technologies to raw waters experiencing water quality imbalance and current HAB reports of harmful algal blooms. NBioorganics has offered their treatment technology at no charge to us for a few case studies in California. If we can find some willing partners who are willing to do the water quality testing, they will supply both the technology, which is maybe Dave Karen could elaborate on when I'm done. Just basically the bug in the jug, proprietary in some ways, but you know, it's been used for years in wastewater, so applied to dirty raw water would be a very similar application. I did mention Bill Taylor and Dave and I as a CCHAB evaluation team wanting to partner with other local agencies, and we have two that came forward this year, one of which is Hal McLean with East Bay Parks and their lake consultant Eli Kirsch with Lake Tech Incorporated. Secondly, we have Pinto Lake working with Jackie McLeod. Both of these agencies have, you know, requested that we be able to evaluate what they've done so far or do some current on-site evaluations with them in 2023. So those are the two upcoming assignments we have for 2023. And that is my report for today. And I do invite Dave Karen to add into anything I might have omitted in my summary.
Looks like Dave is not on, but I think
okay, that's all right. Then I'll open it up for questions for anyone.
Yeah, questions for Hugh?
Hugh, could you repeat the water bodies that you're going to be working on for 2023? I missed the list.
Sure. East Bay Parks over there in the Oakland, Alameda County area with Hal McLean, who's been with our CCHAB mitigation committee as long as I have been. And also, I just spoke to Jackie McLeod yesterday in Watsonville regarding Pinto Lake. And those are the two I mentioned.
Thank you.
Great. Any other questions for Hugh? Awesome.
Yeah,
Well,
this
thank
is Marissa. I just wanted to ask you, has East Bay Regional Parks kind of narrowed down which lake or lakes they want to take a look at with your group?
I spoke briefly to Eli, and I know that Lake Anza and Lake Temescal are the two most frequently mentioned lakes in need of, you know, some support. And Bill Taylor lives really close to those locations. And Dave and I both live in Santa Cruz County. So we're
I see.
excited to get
My
our boots on
location is
the ground
important
and
too.
do a little.
Okay, so Temescal and Anza. All right, thanks.
Sure.
Awesome. Great. Any other questions? Okay, awesome. Thank you both Hugh and Becky for your updates. And I think then we can move a little early to our next agenda item, which is actually talking about reconvening an additional CCHAB subcommittee. So Mike, I believe you were going to run the slideshow, and I welcome you to kind of get your screen up if you would like.
Yep. 1 second. Whoops. How's that look?
Looks great.
Looks good.
All right, I'll advance.
So I think I'm going to start off our group for this presentation. Okay, so this is kind of like our last major topic for the day. So thanks everyone for sticking around, and we really welcome any comments, questions, feedback. Sorry, I got a little bit in my throat. While we go over some of this content, feel free to write it in the chat. We have scheduled like a solid discussion, but if there's anything that you're kind of stuck on, like that doesn't make sense and it would help improve understanding, you can kind of alert us in the chat, and whoever's not speaking can maybe ask a question and that kind of thing. So I'm Marissa Van Dyke again with the California Water Board's FHAB program. And this is the session to talk about the proposal for reconvening the Benthic HABs Guidance Subcommittee. The subcommittee was last formed for about 2 years. They prepared their final recommendations to CCHAB in the spring of 2020. And so after that, sorry, audio coming through?
I'm not, yeah, you were a little glitchy just now, but you're back. So
okay. I'm sorry about that. I was saying that the subcommittee was dissolved briefly, or after guidance.
We're still having
and the thought
interference
okay.
with audio. Yeah, sorry. Let's try one more time and then let's see.
Okay, better audio?
Yes.
Okay, well, let's go back to my headset. I was listening on a different headset. Okay, so I was trying to say that the Benthic subcommittee was dissolved after the adoption, and the plan was to come back when there's new information, new science, new publications to review and consider. And so there's a few of us that want to present today as it's content. There's 3 of us from the FHAB program, Mike Thomas, who's sharing a screen, Carly Nilsson, my colleague, and myself. We've also got some content developed by Rich Vadnais, and he's in the larger SWAMP program at the water boards. And we're also co-presenting with Jamie, one of the co-chairs. Next slide. All right, so we have a lot of kind of like presenters. I just wanted to give you guys a heads up on what kind of content we're going to go through. Just to get us started, we're going to give an overview of getting us into benthic blooms versus planktonic, just kind of transitioning, and then go over what the existing CCHAB networks benthic guidance is, those guidelines, what triggers, what sign, that kind of thing. And for those of you who are already familiar with it from the last couple of years, please consider it as a primer for your upcoming monitoring this year to understand how to use the guidelines when applicable. Those of you that are new, I've got some links in there where you can read a little bit more about it. we're just going to kind of go over that to get us into that. And then we're going to hear from the North Coast Regional Water Board staff. Mike will be presenting their proposal. There's some of their information that they've garnered from their studies. Carly is going to be going over some of the parallel research projects that are going on from the FHAB program and USC EPA that will be developing some content, some data, some science to consider for CCHAB's guidance. And then Jamie's going to go over next steps and timeline for a future subcommittee, and we have a whole chunk of time for Q&A. So please, please feel free to reach out to us as we're talking. Next slide. All right, so we're just trying to get us into thinking about benthics. And I know some folks have spoken to it during today, but to get us back into this, so benthic blooms, we're talking about these potentially toxic algal mats that grow in the benthos. This can occur not just in streams, but also shallow areas of the lake where the UV can penetrate down there. So we're seeing them in large reservoirs, smaller ponds, and predominantly in streams and rivers as well. We're seeing them also in faster moving and slower moving areas. This is like kind of the converse to our more typical blooms that we call planktonic blooms. These are, blooms that float and occur in the water column. We just want to kind of transition this way into the benthics. So next slide. All right, and just a briefly about the ecology of benthics. Some are more nuisance versus harmful and producing toxins. We listed out here some common taxa that we find in California that produce or form these benthic algal mats, including Microcoleus, Anabina, nostoc, Limbia, also we need Microceria, Centonemia, and Cylindrus primarium. And we're finding that different taxa grow on different substrates. So some like slower moving areas, water, and some are found more in the faster current. Oftentimes when you're having a benthic bloom, it's not something easily visible from the shoreline. Oftentimes you see, clear water. And then once you take a look further, then you see that, the benthos can be pretty much covered with the benthic algal mats. Sometimes it's also just kind of disparate, maybe 10-20% cover. And these can co-occur with planktonic blooms too. So in slower moving areas, you can see that. Next slide. All right, and then this is a schema of the life cycle of benthic mat development that we like to share, just to kind of orient us again about like the growth stages. So generally, there's this colonization stage on the left where mats, some cyanobacteria start attaching, and there's some competition there. They're kind of like a very low density. Once mats develop, then you've got this accrual and growth stage where smaller patches can become larger. This can happen somewhat fast as well. And then along the growth cycle, there's also the detachment phase where it can be eroded. There can be some die-off, pieces that break off. Then, you can also have regrowth as well. And, with the density that these blooms can cover is concerned, and also when they detach during their growth cycle, that's more of the public health and animal health risk. Next slide. And this is highlighting again, like the more elevated health risk scenario where you've got that detachment of mats, and you can see on the left, there's plenty of mats still growing, but there's still, quite a bit detachment during that cycle. And, some swimming holes can have then like that stranding of the mats. It can be accumulating at the surface. It can be accumulating along the shoreline. And that's where we're most concerned about potential ingestion of the mats from dogs, livestock, and from children, particularly on beaches. Next slide. All right, so then orienting us into like the public health considerations. So the guidance that was developed took into consideration the primary exposure route, which is again ingestion of the mat material. They evaluated the exposure to dogs and children, saw those at the most risk, and considered them in the guidelines, and then also the signage messaging as well. And with that signage messaging, you'll see like that there's quite a bit different messaging for planktonic blooms versus benthics. Right, so with benthics, oftentimes the waterway just doesn't look as ugly. Like when you're walking up to the shoreline, you don't have that foamy, filmy, scummy kind of look or spilled paint. It's something that you have to kind of like take a closer look at. And also, in comparison of these two types, there are no toxin-based trigger levels for benthic blooms as there are for planktonic blooms. And that's something that you'll see if you look at side by side the guidelines for both types of blooms. There's only one trigger level sign for advisory, which is a yellow banner, similar to the planktonic, but then it stops there. There's no further signage that can be triggered as escalating toxins, concentrations increase, that kind of thing. Next slide. All right, so let's take a look at the guidance, in particularly what's on the signs. I think this is the best slide that I have with like the biggest pictures of the signs, so you can take a look at this to get refresher or take a look at it for the first time. So there's two different signs. Only the one with the yellow banner is considered an advisory sign. Something that was important during the development based off of feedback from CCHAB members was to develop a sign that's just generally just provides, awareness to the public. We call this a general awareness sign. Many other entities have created general awareness signs for planktonic blooms, and they, over the years, and they were well received, quite often requested from entities to post up actually year round, particularly when there isn't monitoring, just to inform the public of what could be occurring and what to look out, and more educational. So part of the guidance was to develop this green banner, more, less alarming sign to educate. And then there's the one advisory sign. And the advice on here is mostly preventative practices to reduce the risk of exposure to algal mats. So if you look at that yellow sign, it says not to allow children to touch mats, eat it, play with it, and not to let dogs drink from that water or get in contact with those mats so that they can consume them. Next slide. And you can read more about the guidance and how those guidelines work. We've got just general FAQs for algal mats to get you into like a primer on the subject. You can compare the different signage for planktonic and benthics in the FAQs for HAB signs. And then we've got the whole guidance, no matter what kind of bloom, laid out in your response, the response guidance webpage with lots of links. Next slide. All right, so just wanted to hone in again on a little bit more about what triggers advisory sign for benthics, particularly since other presenters are going to be talking about that. So there's a lengthy narrative that describes the considerations that went into developing guidance and what how to walk through a detailed flow chart. And that full written report is linked here. If you want to take a look a little closer, but generally the considerations, the primary considerations that the group determined were important were, protect children and dogs, focus on exposure route through ingestion. They also consider that oftentimes there's patchy distribution of cyanos mixed with algae. So you got your more nuisance algae, your potentially toxic cyanos. So visual identification without microscopy can be a little bit challenging, that kind of thing. And that there was little information about impacts of how these toxins and mats can impact shellfish and fish. So they didn't touch too much on that. And they also needed to, limit what they put on signage, just like we considered years ago when we developed the planktonic signs with CDPH and others. Next slide. All right, so putting these signs side by side. It kind of helps see what their purpose is. So the green banner sign, again, educational. There's no trigger to post it. So it can be from historical knowledge, that kind of thing. It's not considered a part of the advisory like process, but it's something that's offered. So some folks think of it as an advisory sign. Just wanted to clarify that. It's similar to the planktonic signs as well that have a green background. And the trigger level sign with the yellow banner, this is its purpose is to post at water bodies where there are benthic mats. So these potentially toxic algal mats are confirmed to be present there. And the trigger level is that they were visually confirmed, so that there's potentially toxigenic benthic mats there by either a staff that have a trained eye to actually identify it on the ground, or through microscopy. We have a chart that identifies which cyanobacteria genera are known to produce toxins. So that's the trigger. Or the trigger is detection of cyanotoxins within the mat material. So it's an either or, it's not exclusively just from cyanotoxin triggers. And then when visual indicators are gone, they can be deposted. And this trigger based off of visual indicators is similar to the planktonic yellow sign. From what I understand, the committee that kind of put this together, they saw that kind of synergy. But there is a cyanotoxin detection also as a trigger. Next slide. All right, so I went over the triggers in detail. If you'd like to see kind of the excerpt of what it says specifically in the guidance, there's a little excerpt there. And there's a pretty clear flow chart as well that walks you through what you should do when you've suspected potential toxigenic mats that are present. We ask that you submit a bloom report so that the regional coordinators can support local agencies, local groups on response, and kind of follow that response plan just so that all appropriate entities are informed, and also that local health is informed if there's any advisory sign necessary. When there's confirmation of a mat present, you go to the left, and then you'd post the trigger sign. If there's potentially toxic mats that are not, like you've determined that they're not present, maybe it's just a nuisance algae bloom, you can post the general awareness sign, depending on the amount of recreation that occurs there, or you can just continue monitoring for that potential change. Sometimes there's both types of blooms occurring, so then the rest of the flow chart clearly walks you through which signage to post to be more clear to the public. So some documented concerns with the triggers. I just wanted to highlight a few of those that spat. So again, those passive samplers that are deployed in some areas of California that absorb the dissolved toxins in the waterway. That's again another measure of toxins potentially in mats, and that detects that detection in the spats can trigger then the posting, and according to the guidance. There's concern there. If you're deploying spats where there aren't mats, you're just doing more surveillance. Another concern is that the guidance did not adopt a standard operating procedure on how to collect the mats. If it's a grab sample or a composite sample, that would trigger it. It was a little bit more open-ended. Swamp does have an SOP that could be considered by monitoring entities. We encourage that. It was not at that time adopted as part of the guidance. We've heard a little bit that the yellow bannered sign for benthics appears to be a little bit more alarming in its wording than the similar planktonic signs. That's something that we've heard. And also some suggestions from researchers have been to include additional triggers based off spatial coverage, like kind of percent cover or toxin concentration. So these are some things that we've heard. And I'm going to, I guess next slide, I'll hand it over to our next speaker. Thank you.
Okay, can you hear me okay?
Yeah, I can hear you.
Awesome. Okay, thank you, Marissa. Again, my name is Mike Thomas, and I'm the FHAB coordinator for the North Coast region, a role that was largely spearheaded by Rich Fadness, our swamp coordinator, since 2016. let's see. Okay. So first, some background on benthic monitoring and research that has been conducted in our region. Benthic cyanobacteria have been identified as the predominant HAB issue in the North Coast region. So we have been researching their occurrence since 2016. These efforts led to the release of 2 reports in 2022 that are listed here. We have presented these findings to the CCHAB in the past, and the reports have been posted to our website, so check them out when you can, if you haven't already. And listed here are some key findings of those reports. So during our 4-year monitoring effort, we identified cyanobacteria of concern in our rivers. We also documented the growth of cyanobacterial mats over time. We demonstrated the use of spats as a screening tool for cyanotoxins in rivers. And this is very important because we also showed that water grab samples in the same rivers are almost always non-detect. So spats are extremely useful in capturing and integrating very low levels of cyanotoxins. And our second report really honed in on the appropriate use and deployment links for spats. And we ultimately recommended a 4 to 8 day deployment in rivers. So a big item to come out of one of our reports is what we're calling the tiered monitoring recommendations. Since spats can document changes in cyanotoxin concentrations, our first recommendation is to deploy spats to determine when cyanotoxins are increasing in the river. An increase in spats indicates that cyanobacterial biomass and toxicity are increasing, and this would initiate visual surveillance to confirm the presence of toxic algal mats. And it's that visual surveillance that really gives us an idea of the size, extent, and condition of the toxic algal mats. Once the mats are identified, we would then recommend periodic mat sampling to confirm toxicity, since it is the incidental ingestion of mat material that is the primary exposure route we're concerned about. So what we would like to do is pilot this monitoring approach in 2023 using these recommendations to help us determine when advisories need to be posted. It's important to note that we will be focusing on anatoxins since this has been identified as the cyanotoxin of concern in our region. However, incident response will continue to test for all cyanotoxins identified in the voluntary guidance. So a little more about using spats as screening tools. Because spat results are expressed as a nanogram per gram result rather than the microgram per liter that we are all used to, we really look at spat trends as providing more qualitative information regarding benthic cyanobacteria and cyanotoxins. With the sensitivity of spats, we always expect to see low-level cyanotoxin results. So this does not necessarily mean that toxic algal mats are present. What we are looking for is the increasing trends and elevated concentrations to initiate that visual surveillance and mat sampling. The mat sampling will follow the swamp SOP for composite collection. And this composite sampling is important since we want our cyanotoxin results to reflect the site or bloom rather than what may be present in a small amount of cyanobacteria. So using spats as the canary in the coal mine, if you will, they would trigger additional monitoring. And it is that additional monitoring, the visual identification of mats and the algal mat testing that would trigger the actual postings. The catch is the use of spats is not currently included in our benthic guidelines. So how do we incorporate spats and the pilot approach into the current benthic guidance? Shown here is the upper portion of the flowchart that Marissa just reviewed. According to our monitoring recommendations, the first step would be to deploy spats. When we start seeing increasing cyanotoxin concentrations in the spats, this would suggest that toxigenic mats are present in the system. This would then initiate visual surveillance and the benthic mat SOP for composite sampling. And at this point, or once mats are suspected, we would submit our bloom report. The next step listed as number 2 in the white box there would be confirming mat presence with observations from visual surveillance and cyanotoxin results. Moving to the left side of the flow chart, once toxigenic mats or benthic HAB is confirmed, then we would post our toxic algae alert. It's important to note, though, that these postings are based on that visual evidence and benthic mat results, not based on low-level detection in spats. Now, if we move to the right side of the flow chart, when we determine that mats are not present, we move to continued monitoring and the option to post general awareness signs. And in our case, this would be the continued deployment of spats. So this is just a very high-level review of what the pilot approach may look like and that we hope to incorporate in 2023. But of course, we would likely need to refine some small-scale processes as we dig deeper into the details. So why are we proposing this and what is the purpose of the pilot study? In the North Coast region, we have received a lot of public and partner feedback regarding the current benthic guidelines. There is sign fatigue and public distrust due to overposting. For instance, posting solely due to low-level detection in spats when algal mats are not present, or posting when only a small amount of cyanobacteria are present. We are always concerned with the economic impacts as a result of posting, especially when whole communities rely on river recreation. And we have also heard from local partners that they would be more willing to follow guidance that incorporates new science and information. So overall, we want to implement our research findings in the North Coast region and incorporate spats as a foundational tool in the benthic guidance. We would then share our findings with CCHAB and discuss with the group whether these findings warrant an update to the guidelines. And of course, we feel that all your input is critical to this process, so we would welcome your thoughts and participation along the way. So with that, I think I'm going to turn it over to Carly now.
Yep, that's me. Okay. Next slide, Mike. I'm going to be pretty quick, but it just seems like a really good time to introduce some of our parallel projects that are going on in regards to benthics and how we can kind of like make this like one holistic process. So I just want to highlight that we do have a contract with SWIRP. Jamie as the lead, who is here today. And one of the deliverables actually is developing benthic algal and cyanobacteria mat sampling procedure and lab analysis standard operating procedures. And we haven't started on this endeavor quite yet, but I'm sure it's going to be underway this year. So there's a lot of opportunity to cross-pollinate and get a lot of feedback from this group. And I just want to highlight as well that there will be a technical advisory committee and everyone is welcome. So if you have an interest, please reach out to Marissa and I, and we can put you on the list for when that time comes. Next slide, please. And then one other project I just wanted to bring up, which is pretty exciting, is US EPA is exploring the idea of looking at benthic sampling standard operating procedures as well. There was a pretty very loud comments from all of the states about the need for this. So it's just now in the development stages, but we were really lucky to have US EPA reach out to us in California and see if we were interested in participating. So we are going to have 2 sites included in this project where we have known benthics, which is the South Fork Eel River and the North Fork American River for this pilot project. That's going to happen this summer. And these sites are going to be sampled 3 times, as I said, this summer field season. And then we're going to be exploring a few different sampling methods. So transect method, disturbance, there'll be water samples, as well as spats being deployed. And all of these analyses will be done by US EPA labs out east, but it should be pretty exciting and we'll keep you apprised as we learn more. We're still learning as well. So we're just excited to be included in this. And with that, I think that's all I have to share. So we'll move on to Jamie. Next slide.
Yeah, so I think I'm gonna just wrap all of this up, kind of talking about, we're basically giving the basis of the proposal to reconvene this group. And so we wanted to, recruit members and kind of give you a sense of timeline and commitment that we're looking for. So, this is, hopefully we've demonstrated that the time is right to recruit or to reconvene this group. I think that there's a lot of new topics for the group to work on, including, North Coast pilot project. And so, if you want to go to the next slide, here's how we propose, let's see, one more. Yeah, here's how we're kind of proposing to integrate and make sure that all of these projects are kind of cross-talking to, avoid duplication of effort and get the best possible, products for the time investment. So what we're planning, after, discussion, unless any, there's strong, negative opinions about doing this, but we would make an announcement on the listserv and send a survey. We would recruit membership. We're envisioning a couple different types of membership, including a leadership role, kind of a member, so kind of more of an observer or someone who would be interested in kind of providing review at the end for the products. So the subcommittee will be co-led by folks from Region 1, since they're gonna have their pilot study and we'll want to be reviewing their work products. And so what we kind of envision the draft tasks being is, of course, kind of looking at the pilot amendment and reviewing that for Region 1's pilot study, and then kind of, again, hearing back kind of their findings. And we would imagine then that because the contract work from the FHAD program has a lot of kind of complementary elements, that this group would also kind of serve kind of de facto on the technical advisory committee for that project, be able to look at all of the findings kind of in parallel and work on kind of revised guidance that would then be presented to CCHABs, once we've kind of completed all of that workflow. So we're envisioning our first meeting coming up kind of before the beginning of the summer, so springtime in a month or two. We would then kind of, Region 1 would go off and work on their pilot project, and then we kind of reconvene later this year, kind of after bloom season, because I know everybody gets super slammed during that period, with approximately monthly meetings over, about 6-7 months, and work on developing our revised guidance and present that back kind of in the spring 2024 CCHABs meeting for review and adoption. And so I don't want to take up too much more time, because we were hoping to kind of get some feedback from the group, but that's kind of our general tasks and timeline. And so I think that was, Mike, is there one more slide? I think that was our last slide. Yeah, so I think we want to just open this up now to discussion and see if, people are generally in favor of this, if you have questions. And that would be, assuming all goes well with that, you'd hear kind of from us via email to kind of start to solicit membership. So with that, I'll stop talking and see if, we have questions from the group here.
Mike, do you mind going back one slide to get folks kind of thinking
Yeah,
about the timelines? And
yeah, it's probably helpful to look at that. Yeah, Becky, it looks like you got your hand up.
Turned camera on, then muted myself. I guess going back to, I think, the slide Mike had about how to incorporate SPAT and the concern with sign fatigue. And right now, the posting guidelines are pretty much mute on SPAT. So they don't, it's not incorporated into it. And I appreciate that this is what you're talking about doing. But if the concern is that the current posting guidelines are putting signs out when there may be concern they're not warranted, I guess I'm just trying to figure out, is the concern the way they are now in terms of when things are signed, or the concern that if we brought in SPAT and any SPAT detect triggered it, that would do it? Because right now it's technically not a trigger, but maybe I just got confused on the process.
Yeah, Rich, do you want to jump in on that one, or do you want me to take a stab?
Either way, the concept or the issue that we had was that we were directed upon positive SPATs to put signs out. And so that's our concern is, you know, a SPAT will detect it almost always. There are certainly times when it's non-detect, but more times than not, we'll have a low level detect. And again, we were directed to put signs up based upon that. And that's what we're trying to avoid, is that sign fatigue on low level SPATs.
Okay. And if I can, Jamie, one more follow-up. Do you think there's a different type of cyanobacteria present, or it's just a concern that the amount of growth that you're getting a detection with is kind of below I don't mean threshold in numerical sense, but just the relative abundance is kind of low, but below a threshold of concern?
Yeah, we've gone out there, you know, throughout the year, and in many cases, early in the year when we're getting low level detections, we really can't find any cyanobacteria. Even microsystem producers, we really don't see anything in that respect either. I think it may be where it's a low level, low biomass issue with like sort of constant bleed or something, where it just is, it's released through these very small populations, but it's detectable in a SPAT.
Okay, thanks. And I'd love to participate. Thanks.
Yeah, this is first I wanted to add, because you know, Mike and Rich have been talking to Carly and I about this. Well, I think the situation that you've described as an example that occurred last summer kind of sets the picture a little bit more, that oftentimes, not always, SPATs are deployed in, you know, strategic places to surveil what's coming upstream. And when there's a detection of toxins in those SPATs, let's say this one location where it was to surveil upstream, but there were no mats there when you deployed it, and there's still no visible mats there when you've now retrieved it. The general instruction is, you know, toxins detected, so you should post, and, you know, probably where you detect the toxins, you should post. But we've been talking about, like, if there are no toxic algal mats or any algal mats visible there, is it appropriate to post at that location? And, you know, we were discussing that actually you should go surveil the beaches upstream and post them as appropriate. But, you know, how else do you convey that there are toxins present at this location and upstream? That got a little bit like caused a debate, and we just determined a standard process for the summer on how to interpret the SPAT results in the posting. And so, like, that's where from that one situation, then, you know, other conversations happened, and I think that kind of helps people have a little bit more context on why posting at that location wasn't always beneficial to convey to the public that there's a problem there versus upstream. So it's somewhat messaging and outreach issue as well.
Yeah. And Catherine had her hand up but then took it down, so I don't know if Catherine, if you wanted to make a comment. I also see
sorry, if you don't mind, I will just refer people to the chat and say that, you know, I don't know if this helps round out the answer to Becky's question, but yes, it's important to know if you have planktonic cyanobacteria, and that might be where the toxins and the spats were coming from. For these systems, we know that that is not the case. So this is one question that needs to be answered to follow this pathway. And the second is that the work Rich and Mike have done have determined the genera of concern for the benthics, so that it then also helps us understand when we do see toxin levels, which are we looking for on the substrate to identify the need for toxin testing and posting. So there are, those are the nuances that you'll find in the reports. And so those would have to be nuances provided if there were actual changes to the guidance, that there's some background work for someone to do in their particular system before they would apply these alternate recommendations. So, but that is why we're requesting, as Rich and Mike have brilliantly covered.
Great, thank you. Yeah, and I think that's a good point of like, this is a system where, Region 1 has done a ton of background monitoring and routine monitoring for many years. And so this is a well-monitored, well-defined system. And so that's kind of why this is a good system to kind of test these alternate approaches. But if you were to be considering a place where no one had ever monitored ever and didn't really know a lot about, this would probably not be applicable in that scenario. See, other thoughts or discussion from the group on this? So I think maybe, Marissa and Mike, if it's all right, I would almost want to kind of just take a straw poll at the right now and just see, of the folks, like Becky said, yes, I would love to be kind of involved. Are there other folks that this would be of interest and would want to participate, just to get a sense of, we'll send out a formalized survey and we won't hold you to your commitment at the moment, but just to get a sense of interest.
Yeah, and even just general interest, even if you don't have time to go to each of the monthly meetings, but if you would be willing to review products, that'd be great.
Okay, we're getting several yeses in the chat, and I'm assuming raised hands are yeses. Unless Sarah and Carrie, if you have comments, please feel free to.
Yeah, just saying I'm interested.
Great. Is there anyone that feels strongly opposed to moving this proposal forward? Okay, that's good, right? So I think, we're happy to, if there's any other questions, I know that we've been on Zoom for a long time too. So please, give one more chance to ask questions here, and then we have our contact information here as well. And then we'll spam you on your email with some information soliciting kind of involvement. But I think I'm not hearing any dissenting opinions that we should not kind of reconvene this group. And there are, in fact, a handful of folks that are interested in participating. So I think that, barring any additional discussion, we can move on a little early to our next topic, but I'll just give it takes a minute to unmute. If there's any other topics, give you a second here, or any other questions rather. Good. Anything that you want to add, Mike or Rich or Marissa, before we move on, or are we good?
I think I'm good. Just looking forward to working with everybody.
Yeah, I just want to thank everybody for listening to our pitch and joining us.
Yeah, thank you, folks.
Yeah, thank you so much. Okay, so we are winding down for the day. So the last kind of agenda item is to just talk about scheduling for 2023 for the CCHAB meetings for this year, as well as just getting some ideas of what you all would like to hear about. Today we had a molecular methods themed meeting. We're happy to kind of try to put together themed meetings like this around topics of interest. So to start with scheduling, we typically have a quarterly meeting, spring, summer, fall, and winter. And we typically have our spring meeting in March, summer meeting in July, fall meeting in October, and winter meeting in January. So Nick Morato had put in the chat to make sure that we're avoiding other work group meetings. I know that we unintentionally clashed with the Safe to Eat work group today. So we will kind of look to keep those in mind. I think what we're looking for is, I just kind of, again, I listed out those months really fast. So March, July, October, and January. Are there any kind of major events that anybody's aware of in those months or weeks or dates that we should be trying to avoid?
I'm just gonna say, I don't have kids, but I know spring break sometimes is hard, but there's not always a consistent spring break week. So I don't know if March is gonna hit into that.
Sorry, the mailman's here. If you can hear my dogs. Sorry.
It's okay.
Sorry, they very rarely bark, but they choose Zoom moments to bark. So yeah, I think we can kind of try to keep that in mind. But if any, like Marissa, do you have any,
Yeah, in July, sometimes the timeline of the CCHAB meeting kind of conflicted with the holiday assessment that we coordinate with members. So giving some time to prepare content for CCHAB, I guess, would be appreciated. So it normally concludes by like after the first or maybe second week of July, just depending on where the 4th of July weekend sits. It kind of moves around. That would be a mask of us, but not too late, because then it runs into peak August.
Okay, so that's good feedback. So like towards the end of July is good. I think this is an off year for the HABS national meeting, and so we can make sure to avoid that. I think we can take a look at the typical spring breaks. And then I think just mid-January has been working well to avoid kind of holidays, because we were previously doing it a long meeting in December, which is kind of rough for people. So, oh, perfect. We swapped meetings Tuesday, Wednesday of each month. Okay, so that's helpful. I think then the CCHAB's co-chairs will work together to, I'm so sorry.
It's not bad. We can hear you.
It's not bad. Okay,
yeah,
it's
go
like
for it.
So
Keep
loud.
going.
They never
louder for you.
Yeah. So we can kind of come up with we'll come up with some dates in our next co-chair meeting. So moving on, for topics of interest, we talked a lot about molecular approaches. I don't know if we'd want to have another molecular themed meeting. Okay. And then, okay, thanks, Nick. That's good feedback. We might want to consider moving to April. So I think that, I'm so sorry.
I'll jump in with one idea.
Okay, yeah.
I know one of the things, and I think Hal has brought this up, but I think for it overlaps on the marine side too, which is, coordination with the like fecal bacterium monitoring side of things too. So it might be that we could do a joint or a crossover with Safe to Swim, either on the marine or coastal side, or I forget what the coastal beaches or inland beaches groups. to sort of talk about how we could coordinate that. I know there's concerns sometimes that, you know, can we collaborate or at least communicate different health risks with water recreation. So just an idea of if there's interest on that, or if people are aware of potential speakers, that might be good.
So we have support in the chat from Nick. I think that's a great idea. So I think we could try to do a crossover. Any other, topics of interest from the group? And you guys can also let us know in over email if you would prefer. But if you want to throw anything else in the chat, I think other than that, we can kind of roll, and we'll kind of try to get the CCHAB website updated with our tentative dates so that those are up, put them on the work group calendar so that we don't overlap with other groups. And then I think, unless anyone has any other topics that they want to bring up, we can kind of wrap up a little bit early today. Any other, we had any other announcements or comments from the group? All right.
Great job. Thank you, Jamie.
Thank you, everybody, and look forward to seeing you in the spring.